Hello, welcome to another stream. Hello, welcome. So today is Friday, if I'm not mistaken, and I'm desperately trying to wake up. It's really difficult, but I'm doing my best. So yeah, today is Friday, and that means today, according to the schedule, we're doing a random one-off stream. Random one-off stream, and that means that I pick a random topic and I do it for a single stream. So the topic of today's stream is what 3D graphics in OpenGL. I've been doing some OpenGL in the streams for quite some time already. You probably saw a lot of OpenGL streams. Zozin trying to get into OpenGL programming yet again, but still failing. But all of them were about like 2D. Only one was vaguely about 3D when we did post-processing, but it wasn't really like true 3D. It was just an orthogonal projection that looks lame and fucky-wacky. And also it was like a wireframe shit that is not even interesting to look at. So today I decided to change that and develop something like actually 3D using OpenGL. At least the goal for today is going to be making a cube with not orthogonal projection, with like proper projection. I forgot how it's called. Right, so the projection where the further away the object, the closer it is to the center of the screen. How do you call this kind of projection? Perspective, yes, with the perspective. I completely forgot, yes. So with the perspective projection and also with textures. Yes, that's how advanced I want to become. I want to be able to do 3D graphics in OpenGL, in a new OpenGL with programmable pipeline, with a perspective projection and textures, and maybe with a little bit of like a lighting, like a fog lighting, you know. It's fucking advanced. Holy shit. It's so goddamn fucking advanced. I probably will work at what's the best game development company on planet Earth? What's the best? Electronic Arts. Yes, I will work at Electronic Arts. Yes. What's up, Old9? Hello, everyone. Hello, Old9, Kettison, Beat69, Trim, Kolumbetka, Strihex, Caustic, Mr. Botka, Lucian the 6th, Anaboth, Fire Radier, C2V4, Droka, 87, Apparently Potatoes, New Rose. Hello, welcome. Will there be loot crates? Of course! Otherwise, like I won't be accepted into Electronic Arts. So, yeah. Cheers! Oh fuck, this water is too cold for me. I cannot drink it. I'm still like, even though I kind of like feel better, I'm still a little bit sick, so this water is too cold. I'm gonna put it on my Soviet radiator to warm it up a little bit. Yes. Oh. Yesu, kawai. Alright, so what we're gonna do? Chromium. I want to open the Chromium. So I already have an OpenGL template prepared. So we're not gonna do the OpenGL absolutely from fucking scratch, right? So we're gonna do that from like a little bit less than from scratch. So for anyone who's interested, here is the template, and we're just gonna copy paste this shit, and that basically does a very basic setup. This is a very basic setup where you we over initialize GLFW, load up some shaders and whatnot, and you can also modify the shaders from the file system. That's actually pretty cool. So let's just clone this shit. So git clone, I already have that. I probably have to clone it to something else. How should we call it? We need the project name generator. Yes, we need a project name generator. Where is it? It's somewhere in my gist. Generate py. Yeah. Let me take that shit. Okay. So how many syllables do we want? We want 4 syllables? Yiza Kuzo. let's go with 3. This one is not bad. Kidito. I'm gonna go with Kidito. Whatever that's supposed to fucking mean. Yes. So this is gonna be... I'm not supposed to do it like that. I'm supposed to clone this project like this. No, Biseva. Well, Biseva is already taken, I'm sorry. There we go. So this is gonna be Kidito. I probably have to also... You know what? I could have... Can I just fork this project? But forking project actually never works properly. Yeah, the forking project means something different in GitHub. So, yeah. A small Spanish child? Is that what it's supposed to mean? I don't know. Kidito. Actual 3D graphics in OpenGL. Yeah. So let's put this thing here. Then can I do git remote set URL origin and just boom, and there we go, we have a different origin. Can I determine the number of different bits Hamming distance into integers without shifting and comparing every bit position? I don't know, can you? So, okay. So I probably also want to push that. Push origin master. Push origin master. So probably want to actually put something in the README. Actual 3D graphics in OpenGL. Just a playground repo for learning how to do actual 3D graphics in OpenGL. The objectives. Maybe let's not put up the objectives. Okay, objectives. All right. Render, generate, and render a cube in perspective projection. In Spanish, it means little, as far as I know. Cool. Okay. Texturize. Is this how we spell texturize? I'm pretty sure this is not how. Texturize the cube. Add simple fog lighting to the cube. So these are the objectives. If we manage to make them during today's stream, you're obligated to subscribe to this channel. Yes, that's the rules. If I manage to do that before the stream, this is just the law. You have to subscribe. You just have to subscribe. Otherwise, you're gonna get banned from this channel. So yeah. Okay, cool. Let's try to compile this shite. How do you compile? You use make files. Use goddamn make files. Okay. Alright. And it's took false. The fuck? I didn't even do anything. This shit already took false. Nice template, Zozin. The fuck? Why am I so bad at programming? Okay, so so everything looks okay so far. Do we add? Yeah, okay. Let's put GDB here. So we also use C. Let's put std C11. All right, and let's do it one more time. I have to rebuild this entire thing. There we go. And still false, but this time we do have debug information. We have debug information, so which we can use. Right, I'm gonna run it from within the debugger. Right. And it segfaults, and where does it segfault? It segfaults at compile shader source in an unknown location. Okay, so at least we know that it's somewhere in 59th thingy. Right, 59th. Not even 69 dance game. Okay, Emacs, show me what you've got. So GL create shader, so it couldn't create the shader. That's very strange, if I understand correctly. So, you provide the shader type. Source is null. Well, it... Okay. Yeah, it could be actually. But... Huh. Okay, so let's assert this entire thing. Travis! Thank you. Yes, doubters, get out. Mods, ban all the doubters. Thank you so much, Travis, for 3 months of tier 1 subscription. Thank you, and welcome to our epic OpenGL club. Alright, so let's rebuild this entire shit, and we don't even have an assert. And let's include this assert. I didn't even make any changes to the template, and still goddamn fucking fails. And it still segfaults. It's just fucking segfaults. So what if I go back to the OpenGL template? Okay, so here's the template, and I do have this thing in here. Right, here's the template, right, so it works. It's literally that thing. And if I rebuild this entire thing from scratch, right, I'm rebuilding it from scratch and I run it one more time. It fucking works. It's literally the same goddamn template that I just... What? Ah, there was a PR. I do remember that. Okay, somebody broke my code and I was blaming myself. Okay. I actually did a mistake. So, I'm going back before the pull request. I'm rebuilding the entire thing. It works. Who could that be? Let's actually take a look at the pull request. I don't know, they didn't leave their credentials. I don't know who could be that person. Okay. Let's make a cup of tea. In all honesty, I don't blame you, because, right, if... Like, why did I merge your pull request then, right? So... if I was a better like open source maintainer, right? If I was a better open source maintainer, I wouldn't merge your pull request in the first place. So this bug is still my mistake. So yeah, so I don't blame you. I had moral rights to blame you if I didn't accept your pull request and I was reviewing it, right? Then I said, ah, you made a mistake, please fix it. But I looked at your pull request and I just didn't check it and I just merged it. So that means it's still on me. So yeah, I'm not blaming you. I'd rather blame myself. So the next time I'm seeing a pull request from you, I'm fucking checking everything. I can check in everything. Absolutely everything. It's okay. Does anyone have any questions while I'm making a cup of tea? Yeah, and by the way, if you ever contribute somewhere and they accept your patch or pull request and then blame you for breaking something, you can always use that argument, like, why did you merge it in the first place then? Now it's your responsibility, not mine. I mean, yeah. So by merging and accepting patches and pull requests, you're becoming part of the actually, you're taking full responsibility because you're the main maintainer. Right, so any bugs that contributors introduced are your responsibility now because you accepted them, right? You accepted responsibility. It is what it is. So yeah. What's your sincere opinion on Rust? To know my sincere opinion on Rust, you have to donate or subscribe. Does anyone have any other questions? I'm sorry, my opinion on Rust, my sincere opinion on Rust is an exclusive content that is under the paywall. Sorry. So, because it has too much demand, because people constantly ask me, so that's why I had to put it under the paywall. So you may not know my opinion on Rust unless you subscribe to it. I'm really sorry. So, it is what it is. It's just like, you know. Witness is gifting tier 1 sub to Certain Community. Thank you, Witness. And Imp Your Mind, welcome to our epic Rust community. And we also have a raid from Fangs Games. I hope I pronounced your name correctly. Thank you for the raid. Thank you for opening 35 browser tabs. Welcome, everyone. How are you guys doing? Welcome. So we're just making tea. Nothing special. So you guys thought we were doing like a well, we plan to do like a 3D graphics in OpenGL, but after like a small break after I make a cup of tea. So yeah. Because we had a really rough start today on the stream, so I need to make a cup of tea before I can continue. But the plan for today, I deleted plan for today, so... God damn it. I got so disappointed with the failure that I've got that I deleted plan for today. I wrote the plan for today and I fucking deleted it. Okay, so for those who just joined, the plan for today is gonna be the following. So, objectives. Generate and render a cube mesh. So here's the thing, we're trying to generate a cube mesh, not load it from a file or anything like that. I want to generate a cube mesh and render it in perspective projection. So that's the goal. That's the first objective for today. All right, then texturize the cube, and then add lighting to the cube with like simple fog lighting, I don't know, something like that. So that's the objective for today. We're learning how to do 3D graphics in OpenGL. We're using just a bare OpenGL. So yeah, we're gonna generate the cube mesh and render it in perspective projection, texturize it, and add lighting. So once we've done that, we're gonna be epic 3D game developers, aren't we? So yeah. Yeah, does it make sense? Hopefully that makes sense. So making tea. Prepare your questions. Wasn't sure what you have to prepare, but prepare your question. All right. Will you do PBR? I have no idea what that is. I'm not a game developer. Does anyone have any other questions? Prepare them while I'm making a cup of tea. Purely bred and raccoons. Yes, we're gonna do PBR then. That's exactly what I wanted to do. Oh shit, your hair is grown. Really? Does anyone have any on-topic questions related to OpenGL or 3D? All right, so let's continue. So let's see what exactly was broken and how exactly it was broken. So I'm gonna go to the master. Let me check. So there was a lot of changes in here. So there's this script. And I'm not sure what the fuck is going on. Yeah, that's probably why I just merged it. That's probably why I just merged it, because I didn't see anything super offensive. Maybe it's not about glue, because I was already merging with glue. Right. I think it may be because static. That's the feeling I have. I think it was because of static. Alright, so if I try to build this entire thing and then run it, it suckfolds, of course, and if I remove the static, maybe it won't do that, because maybe with this flag, it just makes too many assumptions. No. Okay, so what if I don't include anything at all anymore? Is it gonna work now? Okay, so you don't have to include glue then. That's really interesting, even though I'm linked with glue. Right, for example, what if I don't link with glue anymore? Right, something like this. Let's actually do it like that. Okay, you still need glue to do this thing, but if you include glue 2 times, if you try to become a 2-time glue champion, it will just suckfold. That is really interesting. Did they forget? Yeah, OpenGL PP also includes the glue. What the fuck do you want from me? Holy shit. What is going on? Why today is such a shit show? Okay, so I think my tea is ready. It's only half of an hour into the stream and everything is already a shit show. I don't understand. What the fuck? Okay, the fuck is going on? So let's actually take a look at OpenGL PP. So there's another example where I did something like similar, if I remember correctly. Was it in probe? OpenGL PP. No, it was not there. I don't remember where I put it. What the fuck is this? I okay, whatever. To OpenGL PP. I have a project called Small PP for some reason. Don't ask why, please. So let me see. I'm gonna git clone. I have a lot of weird folders in here, okay? So I don't remember all of them. So here's the OpenGL PP. In here, we do merge with glue. We do the static thingy, and if I try to build this entire thing, right, I'm trying to build it, and then, yeah, it created the PP, and it works. Yes. What are we doing differently that time? All right. Sometimes Zozin names his project like he just discovered the words. What is that supposed to mean? All right. Okay. This is very strange. This is really strange. So let's go back to the template. Not really template, but key editor. There we go. If I'm... Wait a second. In the OpenGL PP, in OpenGL... Oh my god. Prototypes. Prototypes. I don't see difference. The fuck? The fuck is this shit? Like, why all of a sudden, if I, in this specific project, in these specific circumstances, this doesn't make any fucking sense, but this is the first challenge of today, I suppose. Okay, so maybe we can add some additional flags. Different ways of loading the shaders. So I really need to compare these projects and figure out what exactly is going on. Like, what the fuck? But it has something to do specifically with reloading the shaders. Is that because... Why do I hear inhuman noises? Shader source. It is shader source though, that means it could be something with... What a great start. Holy shit. Should have implemented that from scratch. Initialize glue. Why do I have to initialize glue? I don't give a shit, seriously. We're not using glue. We're just not using it then. Like, I literally don't give a shit, seriously. Fuck that. The fuck is this shit? Doesn't work on Windows, like, I don't care. Like, why the fuck do I need to, like, go through all of that stuff? Holy shit, this is so fucking toxic. OpenGL PP. Why didn't I check that pull request? I'm not... If I see your name on any of your pull requests, I'm checking it 100 times on different platforms. Holy shit. I'm so fucking done with, like, Okay, let's go to the OpenGL template. And fix that in OpenGL template so that it never happens anymore, ever. Nothing better to do than troubleshoot this bullshit. Did you even check? Does it even work on Windows? How does it work on Windows without initialization? Alright, so... Yeah, I also need to copy-paste this thing there as well. Do I still have it in a... Yeah, there we go. So first thing we need to do, we need to generate a cube mesh. Right, we need to generate a cube mesh. So we're gonna keep mesh as the sequence of triangles, right? Right. So here's the cube. Right, here's the cube. Right, and essentially what we need to do, we need to have these sides, right? And we need to split them by triangles, right? So these things are going to become triangles. Not really sure if I'm drawing it correctly, but it doesn't really matter that much. Right. So, and I want to actually generate that mesh rather than hard code it, because I think it's going to be a little bit more interesting. Maybe I'm going to regret saying that, but I just want to, you know, generate it. So essentially, how we're going to generate it? We can try to generate just a single side, right? So once we generated a single side, it should be super easy to split it into true triangles somehow. And then we can essentially transform, like we already have a mini mesh, right? Mini mesh of the part of the cube. And what we can do, we can probably move it then to the side, right? And basically generate another side, right? Like so. Then we can maybe rotate it, right? Rotate it and generate another side. Then move and rotate and generate another side. So essentially, we have one side that we keep transforming and creating the full cube. So this is the strategy of generating the cube mesh I want to go with, and we'll see if it will work or not. So does it sound okay? Sound good? Okay. So let's see if it's gonna work or not. Sounds like linear algebra. Yeah, I lied to you. I said in the title that it's gonna be 3D graphic, but it turns out it was linear algebra. Ah! Imagine going to like a machine learning course, like on neural networks and stuff like that, and discovering that it's in fact a linear algebra, and then yelling at teacher, "What the fuck? I was promised machine learning and neural networks, but this is linear algebra. What the fuck? Ah, risk!" Ah. Yes. It's a linear algebra in disguise. You thought I'm gonna do actual 3D graphics? No, this is gonna be linear algebra. Anyways, yeah, so to generate all of this shit, we need the math library, which I keep reinventing over and over again. So I need vector, like 2D. This time we need a 3D vector. Yeah. Why did I say it like that? Okay, so we need a 3D vector. This one is going to be interesting. Since we're using C, I cannot use any templates. Struct. So it's going to be v3 and it's going to be float x, y, z. But maybe we have to do like a v4 because we're going to do a transformation of our nation with like rotation matrices and whatnot. So yes, that's probably what we need. So let's actually do v4 then. It's going to be w then. Okay. So we need some sort of a constructor as well. This one is going to just take x, y, z. Can I do something like this? It's gonna be float. You know, this kind of shit could have been like a macro, if you know what I mean. I think it could have been a macro. Because sometimes I want to be able to use this in a array context, but if I'm going to use it in array context, maybe it doesn't really matter that much. Okay, so I'm not going to have a constructor. Yes, whatever. The thing we'll need here, so what do we want to do? We want to be able to move, so we'll need to do add, right? So it's going to be v4 a and v4 b, so it's going to be v4. So let's implement that. It's going to be like this. Yeah, we do 4-dimensional game, by the way. We're doing 4-dimensional game. Okay. This is not how we do that, so we have to do a... Yeah, so we're doing like a rival to a Miyagakure. Well, it's kind of easy to compete with Miyagakure because it doesn't exist. Just like Jai. So, yeah, I think this is what we have to do here. It has to be like this. It has to be space, I think. Yeah. So this is going to be before, and this is how we edit things together. So another thing I want to be able to do, I want to be able to scale this entire stuff. Float s. We're going to put it as s. Scale. Cool. That's pretty cool. So I think another structure that we'll probably need is a quad, right? Because I want to be able to just generate a quad. Yeah, let's introduce quad. Type def struct quad before. And we're gonna have vertices, right? So we're gonna have 4 quad vertices. Is that, how do you spell vertices? Vertices. I can never remember. I mean, English, why don't you just use vertexes or whatever? Why do you have to have like a different form every fucking time? Weird language, cannot understand it. Quad vertices, gonna be 4 of them. So, okay, cube, quad, cube, side, and so what do we want to provide actually? We probably want to provide like a size of the side, right? This is going to be size of the side. Let's put like S here, and this is going to be like a quad. So let me think. I'm not quite sure. Do we really need W in here right now? Do we really need it? I guess we'll need it. Yeah, we'll probably need it. So, whatever. So it's gonna be quad result and 0 initialized. So, and how we're generating the quad itself, right? How do we generate quad itself? I actually want to generate the vertices in clockwise order, or maybe counterclockwise, like in some particular order. Counter or clockwise, because then it will be super easy to split it into triangles, right? So we'll probably have to use the gray code yet again. We'll have to use the gray code yet again. Two. So here's what we have. So this is a 0, 0. Then we have 1, 0. This is 1, 1. And this is 0, 1. Right. So I could probably just generate the binary code, but it will go in the order of from this to this, then to from this to this, and from this to this. So, and I'm not quite sure if it's a good order for us, but maybe it is. Maybe we don't have to generate quad right away. Maybe we should just generate triangles. So with triangles, it would be super easy, right? Because you take first 3 points of the quad using the binary code, and then next 3 points. And this is the way you get the 2 triangles, right? I think it would be easier. So that way I can just generate for size t 0 less than, I guess quad vertices, and I need only 2, so that means I have to, yeah. Okay, I can see how to do that, so I just need to do that. Triangles are generally more efficient to render than quads. No? GPU are optimized for rendering them. Thank you. Okay, so let's actually replace quad with a triangle, right? So we're also gonna have something like a triangle vertices. Vertices is gonna be 3. Triangle. I'm gonna call it try. Day saved. Yeah. So we like every stream we have these like day savers that say the most obvious like information. But this time the person was actually asking, I guess. But this no doesn't really imply asking. When people say like no at the end, they're trying to, so like you know that, right? So yeah, thank you. Cool. It's a very useful information. Okay, so how are we gonna do that? So this one is gonna be 4, so vertices, try vertices. So cube side, and here we're gonna accept the size. All right, we're gonna accept the size, and we're gonna accept the triangles. So it's gonna be side, and we're gonna have 2. So we're gonna return 2 triangles. You were asking, I don't know if they're actually more efficient. To be fair, I know nothing. If you're genuinely asking and don't know, right, so I would answer to you that I don't know either. I'm not a graphics engineer. So but all of the APIs favor triangles. So I guess yes. But the other question, why does it matter, right? Like, we just want to implement something that prints something on the screen, like shows something on the screen. Don't think about it too much. All right. So I also want to have like you know, a constant sides, trees per side, right? So it's going to be trees per side is going to be 2. There we go. So now I'm gonna iterate size t 0. GPUs aren't optimized for triangles; they're just cheaper to render. I guess. Trying to find the difference between cheap to render and optimized for. But yeah, sure. Okay, so here goes the first triangle, right? So it's gonna be this thing, right? And then I need to iterate through, say, size j, 3 vertices. Okay, so that means what I'm doing here is just I take the ith side, and within the ith triangle I take jth vertex, right, and I use this one is actually very interesting. All right, this one is very interesting. So I need to essentially take I plus j and use that as an index. Yeah, that's pretty cool. So then what I have to do here is just something like this. Just something like this. So this is going to be x, and this is going to be k1. All right, so we take this thing. Do we need to do anything else? I don't quite think so. So whatever. And this one is going to be something like this. Maybe we don't even need to do that, so we can just keep these two things. And I guess it will generate for us everything. We can try to fill with 0 the rest of the coordinates, so z is going to be explicitly 0 and w is also going to be explicitly 0, and that generates a mesh, like a mesh for a single side for a cube. Who knows why it is I plus j? Why it is I plus j? We'll also probably have to multiply, we'll probably have to convert all of that to floats. This one has to be converted to a float. It's going to be something like float. And we'll have to multiply all of that by the size. So maybe I should call it size though. I really like the use of this constant that I have here. I think they really like explain what I'm doing, but I think more explanation is needed anyway. So essentially, this is a like classical trick of generating triangles or squares with like binary code, right? Because if you iterate from 0 to 3, you're basically generating codes 0, 1, 1, 0. Actually, this one is 0, 0, I'm sorry. 0, 1, 1, 0, 1, 1. So here are the codes. And you can use these bits as the coordinates. You can treat this bit as x and this bit as y, and you will naturally generate the vertices of the cube. You will generate the vertices of the cube. But what's interesting is that the order in which you generate them is going to form this z, right? And we are essentially exploiting the fact that the order forms the z, right? So you can take first 3 of the vertices forms the first triangle, and another 3 forms the next triangle. So you see, they're sort of overlap. So we have to take first these 3, and then we have to take these 3. And this way we generate 2 triangles. And that's exactly what we're trying to do here, right? So essentially we have triangles per side, which is 2, right? So we have 2. Then within each iteration of triangle per side, we iterate through each vertex, right? And to find that index we're looking for, we adding the ith side to jth vertex, right? So we're sort of recovering that index from the 2 nested iterations. So and that should give us the 2 triangles that form the size of the cube. Does it make any sense? Does anyone have any questions with what we're doing here? Another technique is render as big triangle, not quad. Technique of what? We need to generate a quad. This is the description of our problem. We need to generate vertices for a quad as 2 triangles. This is literally the description of the problem. how rendering with a big triangle solve that specific problem. Can you show how this generalizes for different values of tree vertices and tree precise? Probably not, but the thing is I don't care. Like, why do we need to generalize that? I have a very specific problem and I solve this problem. Why do I need to generalize it? I don't have a problem of solving it generally. Why? Huh? What? Okay. So let's try to see if it actually generates anything. So here's the cube site. Where is my main? Where is my main? So here's my main, and I'm gonna put it here. So this is the main. So this is my main. This one is void. Okay, so I'm gonna have like a side which is trace per side. Trace per side. And so what was the function? Cube side. So the size is gonna be 1, we're gonna set it to 1, and we provide the side. We provide the side. Does it return anything? Cube side. Does it return anything? Okay, cool. It's a name of a structure. Tree is a name of a structure. Look, I is a name of a variable. It's a name. It's just a name. It's not a specific term. It's just short for triangle. Yes, because triangle is too big of a word to... People, you're overthinking. One person is trying to generalize some very dumb algorithm. Another one's... What is going on, people? You're overthinking it. This is very dumb code. The problem I'm solving is very simple and dumb. And the code I've written to solve a very dumb problem is very dumb as well. People, stop overthinking. Why are you overthinking everything? Ah! I swear to God, CS education ruins people. Seriously. Because they start to like overthink like everything they see. Like it's just like they're trying to build these complicated mathematical models and everything. It's very simple goddamn code. We're just generating triangles. Like it's just so goddamn dumb. And then you ask those people to design an API and you end up with something like Vulkan. Roger Chauncey, thank you so much for Soding Gazam indeed. Thank you so much for 2 months of tier 1 subscription. Thank you, thank you, thank you. And welcome to our overthinking club. That's right, we're just overthink everything. Yes. Even the simplest task of generating 2 triangles has to be generalized visually with multiple dimensions, with several object factories. It has to be generalized. Anyway, I think we should stop drinking tea. Where is my water? Cheers. Okay, so let's actually go through all of these things. Trees per side. So let me actually try to print the... Oh shit! Let's use my unpacking macro technique to print the vertices that generates horrible compiler errors. Yes. My favorite technique that generates horrible compiler errors. We have to apply it. Okay, so where's the v4? Okay, there we go. So it's gonna be v4 FMT. And what we're gonna have here, how am I gonna even do that? So it's gonna be something like v4 f. Do I want f or do I want anything else? Okay, so let's actually go with f. F. So here is the formatting string, and then we're gonna do v4 arg, and we're gonna accept v4, and here we're gonna do x. There we go. ZW, something like this. So after that, I can just iterate through each triangle, right? And just we can look at them. We could just look at them. Trees per side. Chat is overthinking everything, but streamer is the one writing macros. Cool. You got me. Holy shit, you destroyed me with facts and logic. Oh my god. So okay, here's one per side, and another one is gonna be tree vertices. Okay, so we're also gonna do something like this, and it's gonna be like that. V4 FMT. So a new line, V4 arg. This technique is so cool. I wish the compiler didn't generate horrible errors on it, but it's more of on the compiler rather than this technique. It's just the compilers are shit. Okay. So, and this way we can just generate all of this. Let me see if it's gonna work or not. See if it's gonna work or not. And okay, so that's very interesting. It generated something. So I think it actually went in a very different place. Yeah. So essentially, I forgot like a small mistake here. Made a small mistake here. Okay. Did it recompile? I did not recompile. Okay, so it's gonna be -b, and there we go. So the first one is 0 0 1 0 0 1. So this is the first triangle, right? We're just generating two triangles, chat. We're just generating two triangles, nothing special. We don't need to create like factories or anything, okay? Two triangles. It's very simple. Right, next one is 1 0 1 0 0 1 1 1. Okay, so that makes sense. So the first one is actually the bottom triangle, and the next one is the upper triangle. So pretty straightforward. You see, it's very simple. It's just two nested loops. It's pretty cool. So now, yeah, something like that. Yeah, almost like that. Cool. So how can we do the other thing? So we can start. It's actually like facing like that, right? So the next thing we need to do, we need to transform it and move it probably on the other side, right? So we need to move it on the other side, and that will give us the other side. So then we need to perform another transformation, like maybe rotate it 90 degrees. And from that rotated version, we also need to generate the opposite one. And then the original one needs to be rotated down, and the opposite one needs to be generated. Okay, so yeah, essentially there will be kind of like 4 transformations and generating opposite faces. I think they're called faces. Why do I call them sides? I think they're faces. Worn out places, if you know what I mean. Yeah. Anyways. So I want to actually keep all of that cube side. So let's create a separate, maybe separate module, because I want to keep everything in that module. So how we're going to keep it? I'm going to call it geo. It's going to be a geo module. So if and def geo.h and define geo.h and if geo.h. There we go. Ah, fuck. Oh shit. Oh fuck. Fuck. Oh shit. Alright, so I'm gonna quickly copy paste everything geometry related, and once we implement this geometry related shit, maybe eventually we're gonna actually put it into the OpenGL OpenGL template, and then this OpenGL template will slowly evolve into a game development framework, and then it will evolve into its own engine that we can license and make shit ton of money. And also we're gonna generalize the process of generating triangles. Holy shit, that's gonna be very fucking epic. Yesu, kawaii desu. Alright. Yeah. Absolutely. Goddamn fucking amazing, mate. Alright, so I probably have to just copy paste the implementations of some of the functions. Everyone loves generalization. Everyone fucking loves it. So we have to generalize as much as we can. Oh, Jiayang is here, by the way, I think. Yeah, I see you. Hello, Jiayang. How are you doing? Welcome. Name the engine payroll. What is this? I can't read that. What is this? Payroll. How do you even read that? What is this language? I don't understand it. What the fuck? Why would I even call it like that? It's really weird. Okay, so I'm gonna make another cup of tea. And does anyone have any questions? Oh shit! Don't tickle me, please. Don't tickle me. Okay. Making tea. Prepare your questions. Does anyone have any questions? Equals triangle. Okay, sure. But how do you even pronounce it? Like, I don't understand how do you read these like weird letters that like half English, half Hebrew? Like, what the fuck is this? I don't understand. Just use Latin, bro. Like, why do we need this weird alphabets? Come on. Some of them are even backwards, like, yeah, exactly. When to use OpenGL instead of Vulkan? That's a very interesting question. So, I have like an opposite question. When to use Vulkan instead of OpenGL? To be fair, I guess the valid reason to use OpenGL over Vulkan if you don't know Vulkan and nobody in your team knows Vulkan. right, and you're more proficient in OpenGL, in that case, it just does make sense to use OpenGL. But the question is, like, seriously, like, what exactly Vulkan is solving? What specifically the problem that Vulkan is solving? Because I tried to set up Vulkan on my machine, and it was a huge pain in the ass. And holy fuck. So basically, with Vulkan, you have to pay a huge price, right, of setting everything up and also understanding, like, it's a huge price. And my question is, what exactly I'm paying that price for? Like, I just don't really understand what exactly I'm paying for. Can anyone explain me? Speed. So I presume that the speed gain I get is proportional to the amount of pain in the ass I get setting up Vulkan. Is it really proportional, or is it disproportional? Is it like really worth it? Has anyone measured, like, can anyone show me that, like, the numbers, like, fucking, like, magnitudes bigger than OpenGL, which is equivalent to the amount of pain in the ass I get when I'm trying to set up Vulkan? So are they even comparable? Are the speed gains really comparable to the amount of pain in the ass? For me, it's disproportional, but that's the point that you shouldn't program in Vulkan directly. Okay. That's really strange. Sorry, forgot that VIP badge can post links. Not really. Also, the subscriber badge can also post links. So, yeah. You don't have to be VIP to post links. Alright, so I'm gonna go to the kitchen and turn on the kettle, and then I'm gonna be back. OpenGL is deprecated on Apple's platform. Good. I mean, on Apple you're supposed to use Metal, right? Has anyone tried Metal and DirectX? I really want to try them. I really want to try them and just see how, like, much pain in the ass to use them. Because I heard a lot of good things about DirectX, surprisingly. Primarily from game developers, but game developers are, like, professional game developers are kind of biased because they only work on Windows, so they don't see anything except Windows. So, of course, they're gonna prize their Windows thing, but I don't know. Alrighty, so I'm gonna go to the kitchen. You guys prepare your questions. Yeah, you feel free to ask questions. Wells is a lot like Vulkan. Oh, okay. That's kind of sad, yeah. But it is what it is. It's kind of strange, like, people say you're not supposed to program in Vulkan directly. But somebody has to, right? So, if you're not supposed to program in Vulkan directly, you're supposed to use an engine, right? If I understand correctly, you're supposed to use an engine. But somebody has to fucking write that engine. Like, or we don't care about these people. We don't care about engine developers. Fuck them, right? We're gonna pay them once and we're gonna ditch them. Is that the logic here? Like, I don't understand. Like, how... Because you're not supposed to program in Vulkan, but somebody has to do that anyway. It's just such a strange argument. Like, I don't understand it. Can anybody explain me, like, this kind of argument that you're not supposed to program in Vulkan directly? If you're not supposed to program in Vulkan directly, how do people think things appear? Do they think, like, engines appear out of thin air? it's kind of strange. It's like saying you're not supposed to program in C and C++ directly because you can program in JavaScript, right? But somebody has to write the browser with the V8 engine. Somebody has to do that. Like, what? Like, people literally believe that all of these technologies, they appear out of nowhere magically. Just people don't want to be that person who have to program in it, yes. Fucking classic. Fucking classic. So I moved everything here. Maybe in the future Sony will stream 3D graphics in the fucking Vulkan. Yeah, you think I don't want to program in Vulkan? You think I don't want to program in it? I really want to program. It's just like I cannot set it up on my machine because there's some complications with how old my machine is. So there's other complications, but they're the main ones. So so if I could program in Vulkan, I would fucking program in it the whole day, as long as people watch, because I'm pretty sure Vulkan will give me shit ton of views, but I just cannot for technical reasons. And also, I know how much Vulkan will trigger me, and of course, people will come to just watch me being triggered at Vulkan. You know, old man yells at cloud thingy. But I just cannot do that. I'm sorry. What version of OpenGL? I think something like 2.1, I think. But I think it also can do 4, but it's just like core. Yeah, it also can do 4.5. But right now I'm using 2.1. All right. So let me see. So we have main.c, and also maybe I'm gonna put the src here. Main.c. src. Okay. Does it compile? Doesn't compile. Because we need to include this entire thing. It's going to put here. Size team, so we'll probably have to include stdlib.h io. Yes, she's trolling you. Debated. I just unfollowed you. Okay, sure. You wanna see a trick? You wanna see a trick? So, you won't be able even talk, even if you follow me back. Alright. So, let's continue. Cool, everything seems to be compiling. Everything seems to be compiling, and so we have a single cube. What I want to be able to generate, I want it to be able to have a function to generate the whole cube, right? So this is going to be float size, and we're going to accept cube. Cube trace per cube. This one is interesting actually. Trace per cube. Dot h. So it's going to be trace per cube, right? So we're gonna have something like cube sides. Is it cube faces or cube sides? I'm not quite sure. So cube sides, and then we multiply it by trace per side. Yeah, I should probably call it faces, but I'm probably gonna do that a little bit later. So trace per cube. So this is the basic constants that we have. Trace per cube, trace per cube, and we have to generate all that. Right? We have to generate all that. I was subs to someone, but I wasn't following them because I like to keep my follow list short, and I couldn't chat in followers only. That actually makes sense. So this particular mechanics of Twitch does in fact make sense because of people who not follow you but can get the sub through gifting accidentally. So or maybe you can chat if you subscribe. I don't know. All right, so what we need to do here, we need to take the side, trace per side, trace per side. So I'm gonna do cube, side size. Do we need to apply the size though right away? I think it would make sense to apply the size right away. So yeah, I need to rename side to face. So let me quickly do that. So it's gonna be side, face, cool, go.h, there we go. Cube face. So we know that I actually need to draw. I actually need to draw to understand all of that. So we're gonna have the following the system of coordinates, right? Following system of coordinates. Something like that is gonna be x and y. Right, and then z is going to be somewhere here like that. So I guess z is going to be like positive there, right? So there's also like a left hand and right hand coordinates. Like, does anyone remember how this shit works? Like you try to pretend being like a rapper and try to understand what like yeah, anyway, so z is going to be outwards from us, and x is going to be on the right, or whatever the fuck it is. Your system is left-handed. Are you trying to insult me? Oh, okay, I see what you mean. So it is that. I think I broke my stylus. Oh fuck. Okay, everything seems to be okay. Yeah, so when we generate the face, it looks like this, I suppose. It looks like this. The fourth, the fifth, the minor fall, the major lift, the baffled king composing hallelujah. Alright, so we have this thing, and the thing we're generating, we need to move it along the z according to the size. Major. We actually have a person with a... Is that a reference to the song? Holy shit. The fuck? Nice. So there should be somewhere who's called minor fall. Okay. Holy shit, that's actually really funny. So we need to do that. So we're gonna have sizes, maybe like a count, right? And the thing I want to do, like, you generate a single face, and we're gonna append first face to here, and then the second face, like that, right? So after that, I probably want to move the face along the z-axis, and the easiest way to do that probably would be just do face. Oh, you have to do that for each vertex of the tree. So let's actually go to geo.h. So we have a tree, and let's introduce something like tree, move, or maybe translate. Right, it's gonna be tree, and it's gonna return another tree. But maybe we're gonna actually accept it by a pointer, and we're gonna translate it by like a particular direction, right? So this is what we're gonna have. So, and that way you can specify a direction, and in that direction you can just translate that a triangle. I think that makes sense. Yeah. So let's quickly do that. So we do have 3 vertices. God, I really love these constants, by the way. I really love them. I absolutely love them. All right. So then 3 vs I is going to be equal to v4 add. Did I call it add? Yes, I called it add. So I take this entire thing and I provide the direction, and I modify every vertex in the triangle. I just basically add that direction there. It's a little bit cold in here. I need a little bit more tea to warm myself up. So yeah. Okay. Tree translate. Okay, so I add those things there, and then maybe it would make sense to do it like that. Size t, trees per face. Put on the epic sweater. Only my hands are cold right now, so but not the whole body. So I think it has something to do with my thermoregulation of my body. So I'm not really sure. Okay, so we're gonna put it like that. So it's gonna be I, and we add all of them. After that, we can try to take the face and translate it by a particular direction. So it's gonna be tree, translate. It's gonna be a pointer, and then what we're gonna use is a direction. So I'm gonna just have a special scope in here, special scope, and the direction is gonna be like this. So y and x are going to be 0, but z is going to be equal to the size, right? It's going to be equal to the size, and we're not going to be transforming w, so I'm going to keep it like this then, right? I'm going to be keeping it like this. There we go. So, and that generates yet another face, There we go, and that we can automatically add. We can actually add the faces as we translate them. That's actually a very interesting point. Yeah, so you translate and you instantly add it, right? You translate and instantly add it. Okay, so even though we didn't generate the full cube, I still want to take a look at how much we generated. So I think I'm gonna return the count of triangles we generated, and let's just call this function and see what it returns. Let's see what it returns. I think it's gonna be interesting. I think it's gonna be goddamn fucking interesting, mate. Hello Plexum, welcome to the stream. How are you doing? Welcome. So trees per cube. It's gonna be trees per cube. So it's gonna be 0. Oh, by the way, I think I need to disable the followers mod. Okay. So here's the cube, and we're gonna call this function cube. Where is the... I never actually imported it. Go.c. I should probably call it faces. So there's some problem with the naming. I cannot decide on a proper naming. So here's the cube. Cube face, then the cube. So maybe I should call it output. Well, let's see if it's gonna complain. I'm not sure if it's gonna complain. I'm really not sure if it's gonna complain. So it's gonna be cube and cube. Yeah, it's probably not gonna be really that great, but okay. So this is gonna be 1, and then I provide cube. Yeah, it's probably gonna be shit show. Then I'm gonna do a count. So it returns a count, which I can iterate and print all of the triangles. So this one is going to be count. There we go. Cube I. Oh yeah, and for each triangle we'll have to actually... Yeah, so with the triangles it's a little bit difficult. Alright. So it's going to be J, trees... 3 vertices, right? 3 vertices plus j. Doing it with indices or just disconnected vertices? Disconnected vertices, because it's easier for me to understand. Maybe later we're gonna do that with the, you know, array index. So usually how people do that, they have like a array of vertices and then the separate array of triangles which are indices to the vertices, so we can use reuse vertices. We're not going to do it right now because I don't have enough skill to pull that off yet. Though it probably would be easier to generate, because that way you can easily generate the vertices, right? Yeah, so because generating vertices for a cube is super easy. It's actually a good point. Maybe I should switch to that approach. That's cool. So, and then how do you generate triangles? Well, you can use the gray code, maybe the binary. Would the binary actually give me what I want? Wait a second. So it's gonna be 0, 0, 0, 0, 0, 0, 1. Or maybe actually, yeah, it's gonna be 1, 0, 0. Then it's gonna go here. Then it's gonna be 1, 1. All right. 1, 1. And then suddenly after that, yeah, it goes diagonally here. So I cannot use the binary code to generate the triangles. So yeah, that's totally fine then. So cube faces, not a function. So we don't have it. All right, let's define it. Cube faces. How many faces does cube have? 6, right? 1, 2, 3, 4, 5, 6. Okay. All right. Cube. Yeah, this is a problem. This is definitely a problem. So we need to cube Nah, let's call it mesh. I think that would be actually a little bit better. So it's going to be mesh. So this is a mesh. Geo.c. And in this case, we also want to call it mesh. So here's a single face. All right. See out. What the fuck is this? Is this C++? Get out of here. No C++ in this Christian Minecraft server. All right, so here we have two cube faces. Here's the first cube face with z equals 0. Right, here's the z equals 0, and here's the z equal 1. Z equal 1. So that's pretty much it, I guess. That's pretty much right. So another thing we need to do. Can we just generate look, without rotation? Can we just generate the faces without rotation? I think we should be able to, if you know what I mean. Because that's yeah, you have a cube face, but when you're generating a face, you essentially we're only working with two variables, right? So x and y. So another one is going to be generated x and y, but with z1. Another one could be generated with y and z, and then another one y and z with x equal 1. Yeah, let's actually create, yeah, square, create square, but within the vertex. We could provide what indices to use as x and y, if you know what I mean. Right, so we don't have to really provide the size. Okay, we're not going to provide the size. We're going to provide the faces. Let's call it like a mesh as well. Trees per face, right? Cube face. And we're going to provide index A and B. Right, and with A and B, we can, yeah, we'll basically like provide all of that stuff, but that will require changing this to an array, right? It will require changing this to an array, but maybe I'm totally okay with that. I think I'm totally okay with that. We probably can use unions, so you can reinterpret that either as array or as something else. And since we're programming in C, right? We're programming in C. That's not going to be an undefined behavior. Ooh. Undefined behavior is so fucking scary. Undefined behavior is as scary as row pointers. I don't even know what is scarier, undefined behavior or a row pointers. Chat, what do you think? What is scarier? Row pointers is scary, I see. I knew it. All right. Let me see. So let's do the following thing. This is gonna be like can you, or I can do that, but what? So something like It just will require introducing too many components, so probably not going to do that. We can introduce something like define x, 0, y, 1, z, 2, w3, and this entire thing is going to be just vs define v4 components. Oh, come on, not 34. This is another rule 34, okay? Okay, so this is v4 components. Maybe we can call it comps, and it's going to be CS to indicate components. All right, this one is comps, of course. Comps. And this way, it would be kind of easier to provide the indices for the coordinates to use to generate like a face and whatnot. For generate faces, so I want to remove that stuff. Geo.c, so this is a cube, this is going to be a cube face. Yeah, we'll need to refactor that, so we're not going to use size. I'm not going to use size. It's only going to have a mesh, but maybe this thing is going to be A and B. There we go. This is MB. Okay, so this is VS, and then in here we use CS, where we use A and B. There we go. That's the whole refactoring actually. So now we can address those components of the vector independently, right? So this is a more general algorithm now, hopefully. But do we want to keep the size? Nah, we don't have to. We can actually generate like a 1 by 1 by 1 cube and then scale it by, you know, multiply and everything. It's just not that big of a deal. And you can even do that in a vertex shader, so you don't have to do that in on a CPU. Alrighty. So here is like a face thingy, right? So you have a face thingy. And now you want to generate a cube face. Cute face. Generate a cute face. And so here is the face mesh, right? So this is a face mesh. There we go. So that basically, what it basically does, right? It just fills it up using x and y as the z coordinate, right? As the z coordinate. So when I'm thinking, yeah. But then the next phase, right, has to be generated in a similar way, right, x and y, but with all of the face meshes set up z to equal to 1, right? So yeah, that's kind of interesting. So we can probably introduce another one, which is going to be size TC, right? Size TC. For this size TC, we can provide the value CV paste. And it's going to be face I, VS, J, CS, C, and it's going to be equal to CV paste. All right, so I think it's going to be kind of cool. All right, so we have this face, and then essentially use Z, and you set Z to 0, right? And then to generate the next face, you set Z to 1. And there you go, you generated two faces already, where you have XY square and then the XY shifted by Z, right? So if you want to generate like this face, let me try to do that, like this face. you will have to set z, y, and x as 0, and then z, y, and x as 1. That's what you'll have to do. So, and then you'll generate more faces. That's actually pretty cool, I think. I think it's a pretty cool way of doing that. So after we generate like each face, you have to add those faces to your final mesh, right? To your final mesh. So it's gonna be 0, I less than trees per face, and maybe I can just use it as a single line. It's gonna be mesh count plus plus equal face mesh I. It's too long, so I'll probably have to do it like that. Alright, so and then you add the second one. So let's try to compile that and see if I didn't do any major fucky-wacky. You know, the standard procedure for fucky-wacky. Okay, so we don't have that shit anymore, so we have to be a little bit more creative this time. Okay, so it's gonna be CS, and then this is gonna be like one of those X, Y, Z, and W. So this is gonna be just that stuff. So when we do add, okay, this one is interesting. Oh, actually making them arrays makes it easier to perform the separations. Arch Alestos. Holy shit, thank you so much for 18 months of tier 3 subscription. Thank you. It's very cool, and welcome to our epic 3D club. Thank you. Cheers. Where have you been? Haven't seen you in a while. Hope you're doing well. Hope you are pursuing your dreams. All right, so let's do this thing. So we're gonna have a result which is 0 initialized. Might as well actually do the following thing when I'm gonna iterate through all of that. So tree vertices. It's gonna be A CSI plus B CSI, right? And then we can just return A in this particular case, right? We can just return A. And similarly, we can do size T less than tree vertices plus I. ACSI multiplied by S. We're multiplying everything by S, and there we go. So as you can see, switching to arrays actually have benefits. You can just assume pointers, arithmetic, and use arrays that way, right? Oh, type safety. Type safety. One word. I'm not gonna even explain anything. Type safety. All right. So conflicting types. Okay. So Q.H. So here's the single thing in here. Okay, so what do we have here? Face is undefined, so I guess we have to rename it to mesh then. We already have a shitty type safety in C. Let's make it even worse, of course. Let's just make it even worse. I mean, come on, seriously. All right, so here's the thing. Okay, so in here we don't have to provide anything. Cool. So these are two separate faces. Okay, now can I do something else? So the next thing I want to do ZY. ZY. So let's put it this way. Z, Y, and X initially is going to be 0. Right? Initially is going to be 0. Then I'm going to repeat this entire thing, but instead of 0, we're going to use 1. So we generated the next two faces. generated next to faces. Now, did it actually work? Hopefully it worked. I'm not 100% sure, but hopefully that kind of worked, maybe. Okay. I think it did. I think it did. So we already generated 4 faces for the cube. 2 to go. 2 to go. So this X, Y, Z, W, and another one is gonna be X, Z. X, Z. Okay. So let me see. X, Z, W, 0. X, Z, W, 0, and this one is gonna be similar. It's gonna be 1. There we go. So, and I suppose we generated the whole cube. Right, we generated the whole cube. So also let me try the following thing. After I generated everything, I want to kind of assert. That the count is equal to faces per cube. Cube. Is it cube faces? Trees per cube. Okay, trees per cube. So we need to also include assert. Okay, so and assert didn't fail, so that means everything's okay. All right. So we can use the same mesh not only for the vertex coordinates, right? Not only for the vertex coordinates, but also for the UV coordinates. Oh no, there's so much noise for me today. I would recommend you to calm down, please. All right. So let's continue. How can we even verify that it's actually like working? And I'm thinking, can we simplify this entire stuff? Can we even simplify it? So XYZ, XYZ. We might try to have like array of only these things. Yeah. So let's try to do that. It's gonna be size T. How should I call that? How should I call that? I'm not sure. Case. We're gonna call it case. Right. So it's basically pair of faces. Yeah. It's pairs of faces. It is pairs of faces. And you have 1, 2, 3 pairs of faces. Yeah. So and within that you have 3 coordinates that you're generating. All right. So the next one is gonna be something like this, and the next one is gonna be something like this. There we go. Cool. So, and instead of doing this copy paste, right? Instead of doing this copy paste, we can now iterate through that and just generate it, just properly generate it. Okay. So let's try to do that. It's gonna be size I, and it's gonna be 3. We'll yet to come up with the name for this constants. So it's gonna be like that. And you also have like 2 situations, right? J2. Then we put this thing in here, and we give it like so. It's gonna be case I 0, case I 1, case I 2. Right. And depending on J, we're gonna have different thing in here, and then we use a face smash. Face smash. And within that thing, we'll have to add all of these things in here. So I'm pretty sure with this loop, we will be able to compress this entire copy-paste. I'm pretty sure, right? So there is 3 pairs of faces. Okay, cube, define cube pairs of face pairs, right? It's a face pairs, it's gonna be 3. Cube face pairs. Cube face pairs. And then we also have 3 coordinates. And I'm not sure how to call this particular thing. It's just like a 3D. Yeah, probably it's something like V3 comps. V3 comps. V3 comps. Okay. So, and in here, it's 2 because it's a pair. Right, it kind of makes sense because we're generating pairs. Okay, and here KS face pairs. Yeah, let's call them face pairs. Okay, face pairs. All right, so that's how we can generate all of that. Let me go to geo.h and just put everything here. So cube face pairs. That's very interesting. Cube faces is a cube face pairs multiplied by 2. Does it make sense? Well, I mean, yeah, that's it. Do be like that sometimes. Yes. But I mean, these constants are really useful because without them, this code will be completely unreadable because there will be too many magical constants, right? So like having those constants is actually pretty useful in my opinion, right? So V3 comps, V4 comps, and so on and so forth. Even though we don't have V3, we still have like assumption of having like 3-dimensional stuff. So we still have this magical constant, but this is because it's a pair, it's 2, and it's kind of like, really? We can introduce something interesting. Okay, pair comps. Pair comps, among the components in a pair, right? So, yeah. Pair comps. And cube faces is the face pair multiplied by pair comps. Is it starting to smell like Java? Really? Where? I don't quite understand. Face mesh K? You think K? Oh yeah, it has to be K. Thank you so much. I don't even have any classes in here. How is that Java? Excuse me? Okay, so this seems to be alright. This seems to be alright. So, and we managed to generate like a cube or something. Without rotation and anything like that, we just use this cube face. So yeah, I think that was kind of cute. If you ask me. It would be kind of cool to test that. Is there any simple 3D format? You're supposed to use pairs. Oh yeah, thank you so much. Pairs, compare. H. Pair comps. Pair comps. Yeah, I was thinking about OBG to be fair, but is there any OBG viewers? OBG viewer online. Online 3D viewer. Here you can view your local 3D models online. You have 3 ways to open a file. Use the open button to select a file. Okay, so OBJ format. Wavefront OBJ format. Okay, so here's the vertex. W. List of texture coordinates. List of vertex normals. Do you have to do triangles? How do you do triangles though? Parameter space. Geometric vertex. Vertex can be specified. You have to use vertex indices. Fuck. Zozin, I don't know what you're doing, but I'm helping. Zozin, use that thing. I don't know what you're doing, but you have to use that thing that I heard of. Zozin. No, whatever. Fuck it. I'm not gonna test it. It's just too boring. Or maybe we can just dump the vertices and look at the points and just see if it's like makes sense. Did you try rewriting it in Rust? No, I haven't tried it. I don't even know what is a Rust. Okay, so here's that. And can I actually print it before OBJ format? Maybe. Yeah, let's do something like OBJ. Maybe fuck it. Okay. So it's gonna be just a V. Okay. V1 Zulu. V1. So this is a mesh, and we have to remove that. And then we have CS, which is X. Okay. 1, 3, 4. So since we have W, I'm gonna print it anyway. I'm gonna just print it anyway. So we don't need that. And if I try to run that now, does it look like OBJ file? Hopefully. So we're gonna actually save it to your mom OBJ. So does it have any header? I don't think it has any headers. Alright, so your mom OBJ. Okay, so online 3D viewer. Drag and drop. Okay, I see. So it's font for ants, as usual. Okay, your mom OBJ. Fail to open file. Maybe something is wrong with your file. You can't even explain what exactly happened. Like, okay, that's very useful. That's very useful. Okay, whatever. Let's actually just try to render it with OpenGL. Let's just try to render it with OpenGL, whatever. So we have a tree, and we have just a mesh. And once we generated a mesh, we just need to put it into the objects and whatnot, right? So we need to create a special object. So it has to be a vertex object, right? Alright. I think cube doesn't have to return anything anymore. So I'm gonna go to the GL, and we're just gonna put it like this. So, and then this is gonna be void. And GL.h. Okay, cube mesh. You don't have to do that anymore. Count. Trees per cube, triangles per cube. Okay. Okay, guy. I'm a little bit tired. Just a little bit tired. So maybe we should make a small break. Maybe not. Okay, so I'm done with generating the triangle. So we managed to generate a triangle mesh. So you know what? Wait, what did I lose all of the progress with my readme? I think I did. Because I was spending too much time trying to troubleshoot all that bullshit. Yeah. Okay, so objectives. Generate cube mesh. Done. Can your Vim do that? Can you in Vim take your mouse and just check and uncheck the checkbox in Markdown? Can you do that in Vim? No, you cannot. Your editor is shite. Got him. Vim lost yet again. Vim lost yet again. Your Vim can't do that. It just cannot. It cannot. All right. So yeah, we generated the mesh, right? So one more time. We're gonna flex on Vim one more time. Okay, we're flexing on Vim. There we go. So Vim cannot do that. Vim cannot do shit. All right. Render the cube mesh in with perspective projection, right? So this is going to be the next step. Texture the cube with, yeah, texture the cube. Simple lighting, right? So far we managed to do one step, which is quite cool. So maybe it's even worth doing committing. All right, so this is gonna be like this. Zozin, I don't know what you're doing, but you have to use that thing I heard about. You have to use it. I'm too lazy to understand what the fuck is your objective and what you're doing, but you have to use that thing. You just have to use that thing. Okay, implement, implement what? Ooh, implement cube mesh generator. Okay, let's push that right into the river. Implement your mom. Does anyone even understand what I'm doing and why I needed OBG? Why are we still talking about OBG? People who are still talking about OBG format, do you guys know what I'm trying to achieve at all? I knew it. Okay, so I'm not surprised. All right, so let's actually make a small break. God fucking damn it. All your project are mysterious. I explain what I'm doing every fucking goddamn stream. Right before the stream, like I dedicate like 10 to 20 minutes explaining with details what I'm about to do, what are my goals, why am I doing that, every goddamn day. It's goddamn amazing. I don't know. Anyways, making tea. Prepare your questions. All right. Come on, hit me with the questions. But why did you want OBG files? Okay, I didn't want OBG files per se, right? So what I wanted to do, I generated a mesh of a cube, and I just wanted quickly, roughly, to see if I didn't make any major fucky-wacky. Keyword quickly. Super quick, because I didn't want to waste too much time on that. I just didn't want to waste too much time on that because it's not that important, because I probably did a fucky-wacky anyway, whatever. Just quickly check it out. So what would be the easiest way to check it out? Well, dump it somewhere to some sort of simple format, which is known by other applications to display. I tried OBG, and some random OBG viewer didn't work. So probably because I fuck up the OBG format, or because the OBG viewer is fucked up and I need to find another way. So we see in both of the cases, it's either my mistake or the viewer is fucked up. In any case, I have to go further. I have to learn more about the format, or I have to find a different OBG viewer. In both of the cases, it's too much time for what I initially wanted. What I initially wanted, I wanted to quickly check if I didn't do any obvious fucky-wacky. But I couldn't do that quickly. Because the format is not intuitive enough and the viewers are shit. So I said, whatever, fuck it. Don't want to waste time for that because I have more important things to do. Does it explain the situation with OBG? Does it explain anything? So it's not that important. So like I just don't have that priority. But people always jump on that bike shading stuff, right? So, and that's why nothing is getting done, because people are focusing too much on things that are not important. Viewers are shit? I said OBG viewers, not my viewers. I mean, are you just like trying to find an excuse to get offended? I didn't mean viewers as you. I'm sorry if it sounded like I was directing to you, like I didn't mean you. I mean the viewers of OBG file formats. The application that lets you view the format. So I'm really sorry if you can't fucking do it. I'm sorry. Next thing, somebody clips that out of the context and posts on the internet saying, "Oh my god, Zozin said that his viewers are shit!" Ah! And half of the comment section, he's right. I'm sorry. I'm sorry if it came out like that, but I meant as viewers as the application, or the application viewer. Yeah. All right. Does anyone have any questions? Chat. Why am I shit? I don't know. I didn't think you're shit, by the way. So in that case, the question is not particularly correct. It's an invalid question. What's the app we're implementing in OpenGL? We're not implementing app. We're just shitposting. Why didn't you use QBasic to write OpenGL code? That's a good question, actually. Probably because I don't know QBasic, and it would take me too much time to learn it for this stream, and I already know C. So if I knew QBasic, so I probably would use it, but I don't know it, fortunately. Question: why am I shit? I don't think you're shit, so your question is invalid. Why aren't you using Visual Studio Code? Because it's slow on my machine. I already explained that several times. So, does anyone have any other questions? Because I'm about to make a small break. Okay. So, 3 minutes. It's gonna be 3 minutes break. make us move back. You guys have fun. You're not shit. Okay? You're cool. I love you. Mwah. Oh shit. Fuck. Just a second. Just a mother flippin' second. I need to pour a cup of tea. I'm really sorry that that I'm late. But yeah, just a second. Sorry, had too much pee. So, what are we doing, by the way? What are we doing? Hopefully hopefully everything's okay. FBG. I hear Jonathan Blow is fixing that Björn Strausstrup bug in the C programming language. This is... There's so much wrong with this sentence that I don't even know what to start with. The only thing that comes to my mind after like seconds of pondering on that sentence, like, what exactly do you mean? Did you know that Björn Strausstrup created C++ and C was created by different people? They knew each other though, like, you know, Ken Thompson, Dennis Ritchie knew Björn Strausstrup, they actually worked in the same place. But it's kind of like the languages like created by different people. So, and another interesting thing, like C language is like a standard. There are several implementations of that standard, and when you say you're fixing a language, what do you mean? Do you fix this standard, like 1,000 pages of the document? Is that what you mean? Or you mean fixing like in a specific implementation? Or you mean fixing like implementing a different... There's so... Like, the reason why I stopped at this sentence is because there's so much what the fuck in this sentence, but maybe that's intentional. Maybe that's exactly the reaction you wanted to achieve. In that case, congratulations. That's a good shit posting. So what can I say? So John Paul suddenly, yes, single-handedly overthrew the ISO committee. That's a very good shit posting, Constance Block. Like, holy shit, that's one of the best shit posting I've seen so far, because you got me. You got me good. So, and if it is intentionally shit posting, just like, I have a huge respect. Like, holy fuck, I couldn't come up with that myself. There's like so many layers on the in that shit posting, like so many. Holy fuck, it's like a lasagna shit posting. It's just, you read, the more you read it, the better it gets. Like, oh my god, it's just a piece of art. Mwah. Ooh. Lasagna shitposting. Lasagna, as English speakers say. Or write. They write it like that. Anyway, so what we have? So render the cube mesh with perspective projection. Right, to render the shit with the perspective projection, we need to put that thing into a buffer, right? We need to put it into a buffer. So here we opened everything, here we initialized everything, we reloaded the shaders, everything's okay. So what I want to do, I want to now generate the cube. All right, it's going to be geo.h, and it's going to be trees per cube. So yeah, trees per cube, and this is going to be a cube mesh. And it's gonna consist of cubes. There we go. So then we do it like that. So this is gonna be cube. So maybe it should be called generate cube mesh, right? And you just provide a cube mesh, right? And just generates it for you. All right. So so we need to put that into a buffer. Buffer from mesh, right? And we provide cube mesh and the size of that mesh. So, and probably this entire thing. It's probably going to be GLUint if I remember correctly. So this is going to be just tree mesh, and then we're going to have size mesh count. There we go. And then we're gonna just return 0 in here. So we probably, yeah, we need to go through all of that stuff of generating a buffer, then associating data with the buffer, and so on and so forth. So I think I'm gonna steal some code from something too. Right, something. Is it called rewrite? I think it's called rewrite. So let me see. So here's the renderer, and there is a piece of code that we can steal from here. Let me find it. Yeah, so we need to generate the buffer. We need to generate the buffer. Cunia is a more real language than Jai. Well, I mean, we can laugh at how Jai is not a real language as much as we want, but his argument is that he wants to release an actually good and polished language, which nobody does these days, actually, if you think about it. Like, literally nobody does that. So every time people come up with a new language, they just sort of like hack together like a very simple proof of concept and just put it out there as 1.0, and it's completely crappy, it's super shitty, it like breaks all over the place, it's unusable, and it changes over time. And yeah, he's like trying to do a thing that nobody does anymore. He wants to like completely polish and release like a finished language that you can just use. And don't worry that the code that you wrote it in that language will be obsolete like in 5 years, right? Because that happened to me so many fucking times. Like, I try that new language, I write a simple program in it, and the program is invalid like in a couple of years. Like in a couple of years, I try to compile it with a new version. It's just, well, that doesn't work. So, yeah. So, and maybe he succeeds in that. Maybe he succeeds. I don't know. We'll see. We'll see. We'll see. All right. So we need to generate a buffer. So this is gonna be a GLU int. Maybe I want to split my legs. Eh? Fuck. I3. So goddamn crappy. For fuck's sake, I3. Using Zozin, yes. I actually smashed together Zozin and use, and it actually started to sound like using. Zozin, just use my window manager. Just use it. There's some small inconvenience in your software. Just use my software that I use every day. I don't have such problems. Using. Yes, using. I swear to God, and those people are like actually being ironic. It's just like fucking amazing. All right. So we need to generate a single like buffer ID. All right, and then we bind the buffer. Bind the buffer is going to be GL array buffer. Buffer ID. So then we need to associate the data. So we already have a data, which is nice. So let me see. GL buffer data. I have to provide GL array buffer. Size of. It's kind of different. So it's gonna be try multiplied by mesh count. So that's basically what we're trying to do here. And then we provide the mesh, and this is gonna be. Do we plan to modified. I think it's going to be GL static draw. Right, I think it's going to be GL static draw. We don't plan to modify it. So we also... It depends on the shaders. So in these shaders, we don't have this stuff. Yeah. I think we'll have to update the shaders at some point. GL int. So... yeah, so we're already associating it with the like attribute, so I think it has to be done on a different level. Yeah, okay. So this is the buffer ID. Demo question, can you make Chrome full screen only in its space? I don't understand the question. Thank you for asking it. Alright, so let me see. Buffer from mesh, so that should be all right. So what's interesting is that we also initialize the failed program, right? And we reload the shaders. In the shaders we also don't use anything, so I think in the vertex shader we'll have to... Yeah, so we have a GL position. Oh boy, oh boy, oh boy. Okay, so this is a cube mesh. And this thing is already bound, right? So I don't have to do anything. Okay, so let's compile that and see if it works or not. So it's gonna make -b. Tree. Okay, we don't have that because I didn't include this stuff. It's gonna be go.h generate cube mesh. Oh yeah, so I actually didn't call it properly because I wanted to rename some of these functions. Generate cube mesh, and this one is gonna be generate cube face mesh. Yeah, boy. Cool. I probably don't even need tree translate, so we can just do it like that. So C generate cube mesh. Generate cube face mesh. Float. There we go. Cube face. Generate cube face mesh. Might as well actually put this thing here. Cool. I really like a style integration that I made. So and constantly reformat everything. That's what I wanted to say. Constantly okay, so but this didn't really work. This really didn't really work. Because in the vertex we don't even accept. We don't even do anything with the vertices, so we'll probably have to do something like that. Oh yeah, so essentially, oh shit, this is actually going to be interesting because what we have to do here, we have to perform the draw call, and in the draw call we have to render triangles first of all, right? So we have to render triangles, and how many? So in a GL draw array, what do we specify? How many triangles do we want to draw, or how many vertices? I can never remember. I can never remember. I'm sorry. Okay, count number of indices to be rendered. Okay, that makes sense. So that means we're gonna use vertices. Okay, so that means we have trees per cube, and then within single tree. Tree vertices. Okay. So you see, it's actually these kind of like dumb constants come in handy when doing OpenGL quite fucking often. Like, I'm actually kind of surprised how often you need these dumb constants, right? Because, yeah, it's quite interesting. So it does make sense to actually create them, even though they're like sound really dumb. I think I'll make that. Okay. Because you're kind of like explicitly explaining the what you're doing here. Okay. So that didn't work because we're probably doing all of that shit incorrectly, of course. First of all, we are not even assigning like a GL position properly. GL SL vertex shader variables. So what kind of variables do we have? Also, a lot of shit is already deprecated. Vertex shader inputs. So there's a vertex ID, instance ID. Okay. And the outputs is GL position. Yeah, I guess in the modern shaders you have to use this like location, like layout, right? Location 1, and the input is gonna be like a position, right? So it's gonna be vertex position, and essentially what you're doing here, we don't need the gray shit, right? So we're gonna just put a position in here, and there we go. But that's probably not gonna work properly with our setup. Oh look, syntax error, unexpected new identifier. So at 3. Yeah. I think you have to like use 3AS. Vec4. Yeah, Vec4. Thank you. So maybe it will work on this thing then. Chat is becoming backseaty, but maybe that's okay. Alright, still syntax error. Hi, is this the include GLFW? No, this is Patrick. Okay, so 3000 ES. Alright, okay, so at least all shaders must use the same shading language. Okay. So, let me see. Frag 3000 ES. Okay, no precision specified for type. Hello, Patrick. Hello, Ripcycle. Hello. I mean, the quality of my answers depends on the quality of the question, so just keep that in mind. I'm not intentionally trying to, you know, shit post like that. Is like, yeah. So if you get a crappy answer, well, you have to think about the quality of a question. Very sorry. Okay, so we need to specify the precision. Precision. So I'm gonna steal a couple of shite. Is this from future import memes? I don't even know what you're talking about, to be fair. So it sounds like some sort of a reference that I don't understand, so I'm really sorry. I'm too old for all of these Zoomer memes, I'm sorry, I didn't understand them. Okay, so no precision specified for Vec3. But they did specify, didn't they? Location 0, but how does it have anything to do with the not specified precision? So how does it have anything to do with the problem that I have? Or are you just saying that randomly because of preferences? So it's probably somewhere in a fragment. Okay. Okay, everything seems to be okay. And now, once we solved the problem, actually solved the problem, right? We can think about bike shading. Okay, so we can put 0 here, sure. Why ES over core? Well, let's find out. Fuck, I should have actually said that you need to donate for this answer, but I already studied answering, so I'm gonna answer it. Do you see this shit? This is the only OpenGL 3.0 shaders that I have. Well, I mean, core, yeah, I could probably enable core, but I don't want to spend time enabling it or something. Because GL, maybe I should spend time like enabling it, but I have to spend time enabling it instead of doing work. So this derails everything. All right. Zozin, stop what you're doing and do it the way I want it. I don't understand what you're doing, but you have to do it the way I want it. Stop everything you do. Alright. Okay. So what I was doing, ES. What you're actually trying to solve doesn't matter. What matters is that you have to use the latest version of OpenGL. What you're doing doesn't matter. It just doesn't matter. It's not important. Use the latest version of OpenGL. Okay, so what do we have? So we successfully loaded everything, and okay, cool. Now let me think. So once we have the buffer, right? Once we have the buffer, we need to associate the vertices and whatnot, right? Associate the vertices. I also use location 1 here. So we're gonna have, yeah, I'm gonna just copy paste the whole thing here. GitHub is so dumb. Yep. Okay, buffer from mesh. So this is the vertex position. Yeah, let's call it position, I suppose. It's kind of like that. I don't need to print that, I suppose. So enable that thing and also that thing, but in our case it's actually 0, right? So, and I forgot what exactly we're doing here. So this is going to be the position, right? Oh, okay, so this is the amount of components, and we have version 4 comps. Yeah, we have version 4 comps. So that's basically what we have, version 4 comps. The type is GL float, not normalized, no stride. Use the stride, whatever is that's supposed to be used here. And yeah, so each individual vertex is going to be this thing. Okay. This was a real thing. Someone asked in the forum after watching Chernobyl why everyone is calling everyone else comrade. Is that really people ask? Have you ever come to like to English-speaking country and asked why everyone is calling each other sir and ma'am? Isn't that weird? Like, why do you like? Why would you do that? Like, that's how we refer to our peers. Like we used to refer to them as comrades. It actually became like an very old way of referring to your peers. But in Soviet times, it was a thing. It was just calling somebody sir or ma'am, or you just call them tavarish, right? Tavarish, do we have a minute to talk about something? So it was a thing, like similar to sir or ma'am or something like that. Everyone's named Conrad. Oh, Conrad. Oh, okay, I see. I didn't understand. I didn't understand the. I thought you actually misspelled comrade. Oh, I see. So yeah. What I was doing? I don't remember. Tavash. Exactly. And it still doesn't work. And I wonder why. I wonder why. And you may never know. You may never know. Because it's a... Looks like compiler did an oopsie doopsie and padded something incorrectly in the triangle. Or, yeah. A nice error message, Zozin. Nice error message. So I already did the trick in this thing. And by the way, if anyone want to suggest render doc, it doesn't work with my version of OpenGL. Don't suggest it, please. So I'm gonna enable debugging. So I'm gonna try to enable debugging, and we'll see if it works or not. We make this thing. So enable debugging. This is not how we enable debugging. I'm an idiot. Oh, debug output, here we go. So, there we go. It's kind of sad that you just cannot program an OpenGL. The only thing you can do is just like a copy paste. But I mean, isn't that basically programming? Isn't that basically programming? It didn't even fucking work. It didn't even print anything. Holy shit. Excuse me? Interesting. But maybe it just doesn't work with like GLFW. Maybe it just doesn't work with GLFW. Because in my first that example, I actually used SDL, right? Yeah, why are graphics APIs so shitty? They're not shitty, they're just low level, and they give you a lot of control of what you can and cannot do. You don't understand, and furthermore, you're not supposed to program in them. I don't know how engines are supposed to be created, right? They have to magically appear out of nowhere, but you're not supposed to program in these APIs. They are not for humans. And engines appear out of thin air. Thin air, yeah. That's the main arguments of, like, every time you say that the graphics API is shittier, they're not shitty, they're low level, they give you a lot of control over what you do. This is the first thing. Second of all, you're not supposed to program in them. Go back to your Unity pleb. Are you dare to question our APIs? Know your place, go program in Unity, okay? So that's basically the main arguments every time you complain about either OpenGL or Vulkan. So yeah, seriously, like this is like any argument about like shittiness of API, they're just destroyed with these 2 points. Destroyed with facts and Logitech. That's right. Oh shit. It's probably facts and Logitech. Exactly. So it's probably because I'm using like weird program and whatnot, but maybe not. It got destroyed by Logitech when I bought one of their keyboards and I had to sign up to one online service to configure my new keyboard. Oh yeah, they do shit like that. How are you? Do you know of a tool to view struct layout visually? No. No, I don't. Sorry. It is what it is. It isn't what it isn't. So here is the version 2 components, but maybe num components. Yeah, so this is what you have to do, but maybe, okay, so if I try to, so this is the vertex position, I use position here, so this is the index. What if I put 1 in here? If I put 1 in here and 1 in here, will that work? Will that work? But find out. Oh, okay, that's something. That is something. Okay, maybe I also have to update the fragment. Oh shit, I actually don't accept anything in the fragment shader. But do I need to accept anything in the fragment shader? Oh, we effed a little bit, I'm sorry. Yeah, we had a small F. Yeah, we had a slightly small F. I don't think we have to accept anything in here, right? Because if I just output the color, it should just work, I suppose. Anyways, so maybe we should try to render a single triangle in the buffer. Can we try to render a single buffer, triangle in the buffer? Wait, where am I? This is a template shit. Okay, so this is a correct one. This is a fragment shader. Has to be green. Oh boy, oh boy. Okay, so this is the components. And what if I say that I wanna have only one of them, right? So let's actually render only one of them. So it's gonna be 1. Doesn't work successfully. But if I try to render all of them, something, it says something, I think. No, we didn't say anything. Huh. Okay, what if I try to change it to 0? It doesn't even complain, it never complains about anything. What could be a mistake? What did I do in here? So we have a cube mesh, we generate a cube mesh. And then we create a buffer out of that cube mesh. So then a buffer ID. So the size of that buffer is equal, so since it's a sequence of triangles, then we have a mesh count. We put mesh, static draw. Maybe this is because of yeah, because of the several programs. Real use program. Yeah, reload shaders, you keep using that program. And then we reload shaders. So what if I don't know, mate. I really don't know. So if I put 1 in here and really like 1 in here, because the first thing we generate a triangle, a couple of triangles, X, Y, Z, so it has to be visible on the screen. It has to be visible on the screen, but it doesn't. It doesn't make it successfully reloaded, so it just doesn't see them. So the question is, what am I doing wrong? What am I doing wrong? Okay, let me take a look at my other code that I have in here. It's really difficult to navigate. But maybe I'm gonna actually, like, I have a copy. I must have a copy here. So let's actually clone this copy. OpenGL API is not shit. It is not shit. You just don't understand it. Okay? It's low level, it gives you a lot of control, and you're not supposed to program in it because you're supposed to program in an engine. It's not shit. Zoizin, it's not shit. You don't understand. All right. So what I was looking at. Here are the people that's gonna defend the shitty API. Come on, hit me with your best argument in defense of this crappy shit. Come on. I wanna know more of them. Yes. You're not supposed to use computers, you're supposed to have someone to use them for you. Yeah. Exactly. It's very cool. Super happy. Okay, so is that. So we also have inputs and then we just have outputs, and that's exactly what I use in my shaders. That's exactly what I use in my shaders. Okay, and it was what? I forgot the name of the project I'm working with. Ah, yeah. So this is a main frag. And of course, like, yeah, so if we have to use location 1. Oh yeah, so I had a different location. This, what the fuck am I doing? I accidentally, I'm actually getting so tilted, fuck, what the fuck? I'm starting to do some really weird shit. Okay, so this is not what I wanted. Crimson Dawn. If that fixes the problem, you're getting a fucking VIP. Holy shit. Somebody watches the stream and understand what the fuck is going on. Alright, so could be the problem. So fuck. So it has to be set. I probably have to extend it to even more. I think stride should be how many. Nah. If you put it to 0, it will use like a default value. It worked in my other place, okay? So I'm stealing the code from my other place. So it worked there, it should work here as well. Okay? So, yeah. So it's gonna be mesh. IVS JCSD DV. Alright, so, and in this particular case, the fourth one is gonna be W, right? And in this case, we have to use V4 components. Alright, so here's that face arg, and then face pairs I3 has to be equal to always 1. Has to be equal to always 1. Alright, so that sets W to 1. I think that could be it, actually. I think that could be it. So position 1 for components, everything looks okay. I'm setting 1 value there, and cool. Is it gonna work? Is it gonna work? It doesn't compile because I need to update the thing. All right, I'm gonna probably regret it, because to become a VIP on my channel, you actually have to be around for quite some time, just so I get to know you a little bit better, and I know for sure you're a good person and not gonna screw me up. But I'm gonna do that anyway, because I promised it. Thank you so much. Yes, that was the problem. That was actually the problem. Welcome to the VIP club. All right. All right. So that means here, what do we have to do? Oh, I pressed B. God fucking damn it. I was starting to do like stuff in Emacs, but I was focused on Chatirina, and that's why it's like had B. So I press Ctrl X B and then enter. So to switch to a different buffer, you have to press Ctrl X B enter. And if you do that in Chatirina, yeah, so it actually prints B. So that's how it came about. Oh, Yatanasov is gifting tier 1 sub to Zojin community. Thank you so much for supporting the channel. And Temporus, welcome to our epic 3D club. Unlike majority of weebs, we do think 3D is better. And that's why we do 3D graphics in here. Alright. So, let me see. Yeah, I need to now actually load up the full mesh, right? I need to load up the full mesh. And this is going to be a trace per cube. Okay, so here's the cube, and it looks weird because, yeah, because we start generating it from 0, 0, right? This is actually a cube. It just faces us like directly. That's why you cannot see shit in the mist. It's actually kind of interesting. So it's supposed to be 1, 1. Oh yeah, it is 1, 1. Okay, that makes sense. So I think we need to shift the entire thing. Trust me, it's a cube. Yeah. I think we need to subtract the whole thing with minus 0.5, minus 0.5, minus 0.5. You know, x minus 0.5, y minus 0.5, and z minus 0.5. Minus 0.5, minus 0.5, minus 0.5. So that's what we need to do. Okay, let's see if we can do that. Let's do plus. Minus 0.5, minus 0.5, minus 0.5. Fucked it up. Okay, so this one is gonna be 0. Yeah. So to adjust everything correctly. That is very interesting. I wonder why that happened. Ah. There we go. So we adjusted everything perfect. So I want to do different things now in here. As far as I know, you have to use like matrix shit to do that. So let's do something like this. So mesh fix up. So the reason why it looks so shitty, right? The reason why it looks so shitty is because the way we generate the mesh, right? So, and this is going to be like a mesh fix up that we're going to apply here, and there you go. So the thing now, I want to be able to rotate this entire stuff, right? I want to be able to rotate it. And the question is, how are we going to rotate? Can we rotate it? So as far as I know, in the modern OpenGL, where the pipeline is programmable, right? You don't have to use GL push matrix and also shit like that. You have to basically apply all of the like projection matrices, rotation matrices, right in the shader, right in the vertex shader. So basically, in a modern OpenGL, you have to do everything manually. As in older OpenGL, the OpenGL would do everything for you. And people call it a progress. This is literally, it's more low level, it gives you more control. You don't, it's literally that. Okay, so OpenGL vertex shader rotation matrix. I wanna see some examples how people usually do that. How to write commands in a vertex shader to rotate points. How people usually do that. I just want to see, like, I don't want to see the full example. I just want to see how people do that. So, okay. GL uniform matrix. There is. Okay. So we can assign a matrix and then multiply them. Okay. All right. So we can prepare the matrix in the CPU and just pass that thing to the GPU. Probably the simplest vertex shader applying a transformation. Okay. Matrix is just an array of float. Yes. So is that a problem somehow? I mean, yeah, literally. Matrix for F4. Okay. Let's try to do that. Do I need to implement the matrix for 4x4 so it's easier? I probably should. I probably should do that. So it probably stores them row-wise, right? So I'm gonna assume that it stores them row-wise, just like C. So yeah, let's actually implement that. So I'm gonna go to the gel.h, so geometry. Construct rotation matrix from scratch. Yes. Thank you. Cool. Okay, so we're gonna have here, we're gonna have array of floats. OpenGL allows you to specify matrix ordering setting. Oh, okay, sure. That's actually pretty cool. So that means if I'm programming in Fortran, right, I don't have to, you know, do anything with my arrays. I can just say that the array is column-wise. So the thing about Fortran is that, unlike C, Fortran stores arrays column-wise instead of row-wise. So, and which creates a lot of fun things when you're interoperating between Fortran and C. So yeah. Alrighty, so what we're gonna have here is just that. Do I really need to do that? Maybe not. So we also want to have different like rotation metrics and whatnot. Rotation metrics. Big endian. Oh, okay, here it is. So this one modifies. We actually need to rotate X and Z, so we need this thing, I think. Oh, and by the way, I think it has to be like 4x4. Okay, rotation mat for X for Y. Isn't it cool? I think it's goddamn fucking cool. So it's gonna return mat for X4, and we'll probably also want to accept the angle. So there we go. So I don't really plan to rotate any like in any other way yet, but we can try to do that. You want to rotate the points in screens, which way is Z? That way. It's there. Alright. So what do we have? Let me see. And now I lost everything. Now I have to scroll down yet again. Ah! Alright. So let's try to return something. It's gonna be mat for x4. And what did I do here is it's actually vs, right? It's gonna be vs. Oh, wait a goddamn second. It's actually 4x4. So what I put there? I think for yeah. So I think I have to put ones at the bottom. I have to put ones at the bottom and zeros at the right, if I understand correctly. I think that's way. Angle. Sin angle. I think this goes to 0. This one is also 0. This one becomes 1, and this one becomes 0f. And this one becomes minus sine angle. Minus sine angle. So we'll have to do it like that. I want them to be aligned perfectly, chat. It is very important for me because I have OCD. Oh, forcing CD. Okay, so it's gonna be cosine angle. Ah, shit. Oh, fuck. I don't quite remember. So essentially, this gives you the ability to add additional things because so this one is gonna be like this. So I'll probably have to figure out one more time. All right, so the bottom line, so if we're doing it like that, so here is the row and then the vector is gonna be a column, right? Vector is gonna be a column. So this thing just allows you to add additional stuff to the original, to the component. So that means these things should stay zeros. These things should stay zeros. Specifically for W, right? We don't want any of the components to affect W except the W itself. I think this is how it's gonna go. I think. Yeah, so if I understand linear algebra correctly, I debated so many people into watching linear algebra instead of 3D. Ah, Zozin, I thought it's a 3D graphics. Why the fuck you do linear algebra? Ah, got him. Oh yeah, thank you. Thank you, Anabufu. Thank you. Tricked into maths again. Yeah. Cool. So we have a rotation matrix. Trigonometry. Yezu, kawaii desu. Yezu. Okay. So where is that example with shite? Where is that example with shite? I don't see it. Did I close it? Fuck. Here it is. So this one is a uniform mat 4. I should have actually called it mat 4 as well because it's makes sense. Okay, so let's just go ahead and do that. I'm gonna copy paste this code. Excuse me. Using a matrix to express translation means turning 3 additions into 16 multiplications, the pinnacle of optimizations. But I mean, GPUs are optimized for this kind of computations, aren't they? So we have a program, a generate cube mesh, and we need to find the location, right? So get uniform location. Okay, so GL uint U matrix, no U matrix, no U. So when I reload the shaders, do I have an access to the program? Is the program a global thing? Oh, okay, so it's gonna be a main. Where is the program? Okay, so it's global thing. Alrighty. So then we're gonna construct a matrix. Right, it's gonna be mat4x4 matrix. And so maybe it makes sense to keep track of an angle, because why not? So here's the matrix, and I need to set this entire thing. So it also accepts some sort of a GL false. I have no idea what the fuck is that supposed to mean. U matrix GL false, and then we provide the matrix. I suppose we provide it like that. Let me see what the fuck is that thing, because I'm not quite sure. So wait, matrix, okay. Count. Specify the number of matrices that are to be modified. Okay, one transpose specifies whether to transpose. Oh, okay. Into the uniform variable. Okay, so that's cool. So you don't transform and just use it like that. Okay. So we don't have a sign. Probably have to. Oh yeah, it has to be angle. So we have to import math. Math.h. Cool. But we don't have that yet, so it has to be linked appropriately. Okay, that's pretty cool. But you know what I also want to do? I also want to use conf. You're doing so many projects at the same time. Are you a pro programming streamer? No, I'm an amateur programming streamer. Sorry. I'm just an amateur. Cool. Now, we're gonna try to update the angle on every frame. Are you guys ready? This is how you update the angle, yes, with these kind of sounds. And guess why this doesn't work? Because we never fucking use the matrix, of course. So, alright. Matrix. Do we have to multiply or do you have to use dot? Okay, multiplication is just like a. Yeah, probably makes sense. Yeah. So this does make sense because it's an orthogonal projection. So yeah, so we have an orthogonal projection and that's why it looks like a little bit weird. So, but our goal was to actually do that with a perspective projection, right? With a perspective projection. And the question is, how can we achieve the perspective projection? It's a very good question. It's a very, very good question. How can we achieve... So we probably need to use some perspective projection metrics and also multiply it with the rotation and whatnot, maybe. Well, we'll see. We'll see. Okay, so perspective projection metrics. Perspective projection metrics. I think the error is you also multiply the fix. Yeah. It's not an error. It's intention. Trust me. Trust me. I'm a professional software developer. It's intentional. Can you just give me the matrix though? So let's take a look at this matrix. This looks kind of interesting. Thus we have a final version of our basic perspective projection. So S is equal, holy shit, that's a lot. Can we have something more simple, please? That'd be actually kind of cool, I think. Maybe I need to read this thing. I know that the simplest projection is basically multiplying. Okay, OpenGL vertex shader projection matrix. Vertex transformation. Projection. Computing the projection. The vertex, the projection matrix for the perspective projection. Alright. Just divide x, y by z. That could work actually. We did that when we were doing like a CPU rendering. But maybe that's exactly what I'm gonna do, because I don't really want to spend too much time on this kind of stuff. Anyway, so I want to make a small break because I need to pee. How many minutes I want to have? 2 minutes. I think 2 minutes should be okay. Should be all right. 2 minutes should be enough for everyone. Right, let's make a small break. You guys have fun. Yo, what's up? How everyone is doing? Welcome back. So let's go to geo.h and introduce maybe perspective metrics, right? Some sort of a perspective. Some sort of a perspective and projection. So I don't know what that thing is. Oblique perspective projection. Standard perspective projection. So this is orthographic. So I'm just thinking, which one should I pick? So the standard one looks easy, pretty easy. So we have these parameters. The standard perspective is characterized by angle that specifies the field of view in y, as illustrated. Okay, so here is the field of view. The distance n to the near clipping plane and the distance f to the far clipping plane. Okay, that makes sense. The aspect ratio a of the width to the height of the center rectangle to the near clipping plane. The distance aspect ratio of the width to the height of a centered rectangle on the near clipping frame. I don't understand what is A. I don't understand what is A. The width to the height. Okay, width to the height of a centered rectangle on the near clipping frame. So this one, width to the height of this rectangle. Do I understand it correctly? Holy shit. So width to the height of this one, I guess. Okay. Holy shit. I don't know why it was so difficult for me to understand, but okay. Standard perspective projection. Okay, mat for x4, standard perspective. So, and I guess we can just, oh yeah, by the way, so rotation matrix is probably gonna be Woody Bitepack. Thank you so much for tier 1 subscription. Thank you. Your first subscription, by the way, and welcome to our epic projection club. How about that? All right, standard perspective. Thank you so much. Thank you. Okay, let's see. So we're gonna put it here. Byte packer, yeah. So this is gonna be angle. For what can call it field of view. Then A. It's gonna be float A, float N, float F. Oh my god, I'm running out of steam so hard. Holy shit. Okay, so we just need to construct all of this thing in here. And of course, if you resize it like that, it's not gonna work well. Standard perspective projection. Here it is. So I just need to retype it really carefully. All right. D. One, two, three, four. Another one. Holy shit. With D. Oh, okay. I see it now. Holy fuck. just more levels of indirection, of course. Just add more levels of indirection. Okay, so this is going to be float const d equal 1 over tangent. So it's probably something like this: 4v multiplied by half. I don't remember the name of the function. So d over a 0, 0, 0. 0 d. Just everything's okay. I'm sorry. Okay. Why didn't you add like a layer, like level of indirection for these things? I don't know. Like you added it for this one, for this thing. No, we're not gonna do that. I don't know. Alright, so this is going to be n plus f divided n plus f divided by n minus f. So this is the thing. It's going to be like that. And this one is going to be 2nf. Okay, 2. I wish I could understand what the fuck all of that means, but I'm not supposed to, I think. Right. It's none of my fucking business, right? Just use an engine. Don't try to understand that. Just use a goddamn engine. Stop wasting your time. It's already solved problem. Stop solving problem of a game engine yet again. We already solved that. We already have Unity, so stop. I actually had people who unironically told me that. It's like, holy fuck, it triggers me to this day. I'm not even sure if they were trolling. I hope they were. So, but what's interesting is that you can probably do all of that without this shit. So I suppose first thing we want to do, we want to rotate the matrix, and only then we want to project it. So we'll think how to do that. Oh, also I need to multiply them, but I can multiply them later, I think. I can multiply them on GPU. I know how to multiply them myself. Yeah. I don't have to multiply them myself. So if I try to build this thing, control reaches. Thank you, compiler. Very cool. Such a useful error message. The error is in a completely different fucking file. God fucking damn it. So bad. Zozin, just use Zig. Okay, so this seems to be working. So what do we have here? Uniform mat4 proj matrix. So this is another thing. And essentially the first thing we probably want to do is just projection matrix, then multiply it by the rotation matrix, and that should work. Zozin, you don't like C, just use Zig or Rust, or just use one of these languages. Okay, what's the next thing? So we need to have a uniform for this thing, so we're going to proj matrix. Here's the proj matrix. We can probably like assign proj matrix once. Can we? I think we can. Just use giant. I'm not better enough to use giant, I'm sorry. I'm not John Blow's better. Okay, so here's the matrix. It's gonna be proj matrix, right? So how is it called? Standard oh yeah, you also have to provide all of these parameters and shit. God damn, bruh. God damn, bruh. So what's gonna be the best set of parameters? What's gonna be the best set of parameters? Specify the field of view in a y direction is illustrated. Okay, so let's actually put in. But what is it? Is it in? How is it called? If it's a tangent, right? Probably it is in radians. So it's pretty safe to assume this is in radians, and 90 degrees is half of a pi, if I remember correctly, right? So some half of a pi. Half of a pi. Okay, the distance n to the near clipping plane. I don't know, let's put something like very, very small. Near. So A. Oh, wait. Okay. And near clipping plane is gonna be like 0, 0, 1 or something. And the far is gonna be like 2, I think. So, and A, I guess 4 to 3 is okay, I suppose, yeah. 4 to 3 is gonna be okay. So, this is a proj, and we have to do it like that, proj matrix. I wish I was able to do like lunch breaks on my streams, because quite often like I'm finishing the stream because I'm too tired to continue, but then after the stream I have a meal and I feel a little bit better. I feel like I could go for another like couple hours, but I already finished the stream. So unfortunately for me, making a meal is just too much work, because it takes like roughly an hour. I don't keep any prepared food in the house because I'm a very compulsive eater, and if I have anything that is already prepared, I'm gonna just instantly eat it. So the only way for me to stop doing that is actually not have anything prepared and force myself prepared every time I need to eat. So I cannot just prepare the food and, you know, have a lunch break. I just cannot do that because my lunch break is like one to 2 hours because I'm cooking. So yeah, it's kind of sucks. Kind of sucks. This is what it is. Anyways, thank you for the rate with 3 browser tabs. Hello, hello, Iris and X. Thank you so much. All right, so let me see. So what is it? We wouldn't have pi. So pi. Okay, so that didn't do anything. Nice. That didn't do anything. So if I don't multiply the by projection matrix, right? If I don't multiply by projection matrix, is it gonna do anything? Yes, it does something. But what if we multiply only the projection matrix? It doesn't do anything, so it doesn't work. It literally doesn't work. So, does anyone have any ideas why? So, why it doesn't work? So, the thing is... main.c. So I get the projection location and I set this thing once and I don't try to modify it every time. Trying to modify it every time. Maybe you're behind it. None of that worked. Literally none. Okay. Let's just go through all of the shit one more time. Too many suggestions. Okay. So we have this, that, and near frame. Okay. D over A 0, 0, 0. Okay, D over A 0, 0, 0. 0, D 0, 0, 0. Okay, that makes sense. 0, 0, and plus. I'm pretty sure it's plus. It's really difficult to read, but I'm pretty sure it's plus. N plus F divided by N minus F. Okay. So 2NF, right? 2NF divided by N minus F. So it is true. Okay. 0, 0 minus 1, 0. Don't see any problems in here. Everything looks okay. So then tangent, it's a 1 over tangent F of V half. Don't see any problems. Yeah. Here's the Z. Fuck. Fuck. So maybe we need to update the mesh then. Okay, so how do we generate the mesh? So we're gonna put 1, this is a 0. We can actually put that in a fix up, I think. Alright, so here's minus 0, 0, 5. So we put that thing there, but we also want to actually put it away slightly. And so in terms of 0, it could be actually 1.5. So nah, it didn't work. It didn't work. So we had it like this. I brought it back to here, and then I'm subtracting more Z so we can see it. I think you need to use GL true in the call to GL uniform matrix. Any arguments to back it up, or just a random guess? Okay, so all right. I don't really care about random guesses because they usually don't work. Distance. Is it really has to be negative? It really has to be negative? So, your metric is in row major order, but GL false means. Are you sure about that? Where does it say is in the documentation? Could you show me in the documentation that it means exactly that, or are you just guessing it? So. Source, trust me, bro. Okay, so I'm starting to regret actually giving you VIP. Okay. Transpose specifies whether transpose metric value are loaded into uniform variable. It doesn't say anything here, so we have to read that a little bit further. Just trust me. Regret giving you like every time I say like it's exactly as I said. I'm gonna probably regret it, and I already regretted it. Okay, so let me see. So here is the interesting thing. Where is the here it is. Yeah, they have to be negative apparently. Okay, so let's actually put -1 in here. Let's put -1. Mm-hmm. Of course, you're not gonna tell me where exactly it's written, so you'll force me to read the entire thing. Okay. Matrix. Isn't row. No, don't reload it. Row wise. Okay. Just trust me, bro. Yikes. Okay, there's some discussion about that, at least on the internet. If you drop, forget about the row column measure thing. So it's row wise, okay. By the way, here's an argument. If it was like row-wise, it wouldn't work with the rotation matrix. Right. Essentially, here's me ignoring the projection, right? Right, and then I'm using the rotation matrix. So if it was in an incorrect format, I'm pretty sure it would just not work. I didn't apply the fix up. But it worked before, so we changed something in a different place. So rotation matrix is the orthogonal. Okay, that's a good point. But again, okay, you all say that it is like that. But can anyone provide at least a link where it fucking is? It's like, are you guys okay? Like, just show me where it says that it is column-wise, not row-wise, and everyone is silent. And everyone says, just trust me, bruh. Are you fucking serious? And you expect me to believe you? Just send the link then! Oh my god, I'm not listening to you. Like, I'm so disappointed. I'm so goddamn fucking disappointed. Holy shit, I'm disappointed. Just trust me, bro. It's on that link. It's on that link. Search for transpose. Oh, shit. Oh my god. Just, you're literally wasting my time. Let's just trust me, bro. It's on the page. Yeah. Transpose. So. Fucking finally. You're not getting back VIP. Seriously. That's a good way of wasting my time, seriously. Tricking into thinking that you can actually provide like some useful advice. So I listen to you, trust me bruh, for like a half of an hour. No. Okay, so I'm gonna try with the positive things now first. So this is gonna be a projection. Way to waste my time, thank you so much. Okay, so that's pretty cool. Could probably fix it myself by googling around without like listening to the chat way faster. Okay, so there's something wrong with the rotation matrix. The rotation matrix, by the way, stopped working for some reason. I'm not sure why. So this is probably because I modified the... yeah. So what's up with this thing though? Okay, so it seems to be working as usual if I don't do the fix up. So I suppose I have to do like oh my god, proj matrix. So I would expect it will apply. It must apply. How does it apply? I'm not even listening to you. Okay. So the projection kind of works. But I'm not sure about the order. So can I specify the order like this? So first I wanna actually rotate it, right? So this is first thing I wanna do. First I wanna rotate it. That is true. So here is me rotating it. And projection matrix. Then I wanna project it. And there's nothing there, but it should. It should actually work. So maybe I should also put true in here as well. Oh, Emacs is being too slow. Okay, so what if I have a rotation around Z? So will I be able to see that? Or maybe I cannot see that because it's clipping or something. That could be it actually. So here is the fix up. We're rotating this entire thing, and then maybe I want to do like vec for 0, 0, minus 0.5, like this. So to shift it a little bit. So why wouldn't it work? Why wouldn't it work? Why wouldn't it work? Yeah, they're just wasting my time. I ignore them. Because it's kind of like I want to first rotate it, right, and then I want to project the final result. So that's what I'm trying to do here. Okay, so here's the position. If I change the order, well, I mean, it never works, but Yeah, it does. It starts doing something really weird. But it could be actually clipping. If you think about it, it could be clipping. Also, maybe I have to make this thing negative. Who fucking knows? Let's try to do it negative. Yeah. Also, I think I want to rotate slightly faster so we can see things better. Alright, wait a second. Even faster. Let's actually rotate like this fast. Yeah, I think it's clipping. I think it's just clipping, and that's why it looks so weird. And how can we even do that? So we can try to move again, vec4. So that makes why projecting first though? I don't understand. Why projecting first would actually work? What? What am I missing? I'm missing something very important. Like what the fuck? Right, because in my logic, here is the position. Right, here is the fixed up position. I rotate it first. Right, I rotate it first, so that makes sense. I rotate it first. So here's rotating, and once I rotated it, once I have it in a state as I want to project it. So that would make total sense. So that would make total sense. So why doesn't it work? It just doesn't. It just doesn't work. So I probably missed something. So this has to be like slightly different. And it just does nothing. Like we cannot even see any rotations. It's just like nothing is happening. I don't like this projection matrix. We need a different projection matrix. So what other projection matrices do we have? So this is a standard, like dividing by z would be like way easier to be fair at this point. It's just fucking divided by z without any of this bullshit. So the standard oblique perspective. So FRLT. It's actually a good point. We can check that. We can probably check that. All right. So it would be kind of cool to assign different colors to vertices so we can at least see this shit. Let's actually color these things slightly differently. In a fragment, at least. What is this fragment shit? Okay. Gel frag color. Is that probably that? So it's gonna be X gel frag Y, and I think we can put Z in there. So all of them are 1. Okay, so we can try to do the following thing, where I want to have rotation around Z. Let's actually do rotation around Z. So we need to copy paste Emacs. Come on. A different rotation matrix. So I have too much shit opened up. Let me close all of this shit. It's useless. Something with my keyboard, I think. I wish I could copy paste it. Fuck, it's so painful because now I need to move it here, and if I resize it I will completely lose the place where it was. Oh my god, yes. Oh, fucking computers. How I hate computers. Holy shit. Okay, 1F. So, and has to be like 0, 0, so this one is gonna be 0, sure. This one is gonna be 0. Cosine F angle minus sine. I really want to eat something. Holy shit, I'm so hungry. But I also need to finish, but I cannot have a lunch break. It's just like, it's not possible. It's not a thing I can have. Because of the specifics of my health, I just cannot have a lunch break on the streams at all. So fucking sad. So, and this one has to be 1. Right. So this is gonna be our... I needed Z! Oh my god, I didn't need X. I needed Z. Not funny. Holy shit, why? Whatever. This one is that, and I suppose in this case is gonna be... Okay. So this is Z. Right. I suppose. Yeah. This is Z. No. Let me see. The answer is no. It is not rotating. Because in this particular case, we would have seen it. Alright. Let's make a cup of tea. Does anyone have any questions while I'm making a cup of tea? Making tea. Prepare. Questions. Feel free to ask questions. Come on. Hit me. What is this for? For recreational purposes. Next one. So this project, we need some sort of a simple projection, like some very, very dumb projection. Because this projection is too complex for me to understand and troubleshoot, so we need something simpler. But I want a perspective. I really want perspective. Any questions? All right, I'm gonna go to the kitchen and turn on the kettle. Prepare your questions if you have any. So I think I need to have a more like closer to technical example. OpenGL vertex perspective projection vertex shader. So I need some examples. Projection view transformation. Okay. Translate scale. Holy shit, this website sucks. Convert to the screen space. At this point, I just want to do this. Oof. I probably should finish streaming, but I haven't actually got anywhere near to what I wanted today. Fuck, I hate streams like that. Hate streams like that. Okay. So. So can we just use this trick in... Here's an interesting thing, right? When I assign position in the vertex shader, does it just ignore Z and W coordinates? Does it just ignore Z and W coordinates and just puts X and Y into the fragments? Because it's kind of interesting. Oh yeah, it probably does. It probably does because if it has a Z buffer, it can interpolate not only X and Y, it can also start interpolating Z inside of a Z buffer. So then, yeah, you can do this kind of stuff. I don't know what has scooping to do with all that, but okay, sure. And reject because I have no idea what you're talking about. Would be kind of cool to have a working example. But I'm too tired to have it, so yeah. This perspective sucks. Fuck it. Okay, I guess we're gonna finish the stream today here, because I cannot continue doing it. Wasted too much time, should have stayed focused on this kind of stuff and ran out of steam completely by the end. Yeah. Holy shit, I fucking hate it. I'm gonna feel like shit after the stream, so let me actually make a small break. I wanna pee. We're gonna try to finish something at least today. 2 minutes. Should have focused on the problem. Should have ignored the chat, not listened to anyone. Just couldn't do that. All right, let's make a small break. You guys have fun. All right. We have still too many things to finish. So fuck this projection matrix bullshit. Fuck all of that. So we're gonna have rotation, so rotating over Z, right? So here it is, looks good to me. So I'm gonna do rotation over Y, I suppose. I think it's called Y, right? I think it's Y, and let's see, so it's keep rotating, that's cool. So what if I just try the projection without the matrix bullshit? So will that work to some extent? Okay, so maybe after that, after we rotated everything, we also want to move it a little bit further away. So if I, for example, yeah, we can actually save that to some sort of like a separate position. So vector 4 position. So then after that, we can sort of try to analyze all of that. We can try to analyze all of that. So I'm gonna literally just, you know, do this Z division thingy and see if it does anything. So this is gonna be rotation, and after rotation we want to do a little bit of a translation. I really want to move it slightly to the farther away, but I'm not sure how farther away do I want it. So if we consider like Z being okay, so I think I'm starting to understand. So it's going to be 0, 5, and if I do that, it's not modify. Too few coordinate. Oh yeah, that's true. Okay, that makes sense. Oh. So it is not ignoring Z by default. Or does it? Wait a goddamn second. So... Ah! I'm an idiot. I'm adding W. Of course it just affects the, like, how things are, like, working. So if I add, like, half, right? If I add, like, half... Yeah. So no matter how you put it, like, more far away, it is not affecting anything, at least visually. At least this is what I can say experimentally. Okay. Probably it has some sort of like a clipping. Oh, well, yeah, it's probably clipping at some. Yeah. So it probably starts clipping with. Yeah, if it has like a Z buffer, that makes sense. All right, this behavior does in fact make sense. I really like that. So you know, experimentation is better than reading stupid fucking documentation. So don't explain anything. So now once I have this like thing, it's gonna be like this, and then I can try to craft the other position, right? So it's gonna be X divided over Z, and hopefully Z is not gonna be 0, but it could potentially be 0, so we have to be a little bit careful. So position X divided, actually Y, right? Position Z, and I think we still have to keep the Z value for the potential Z buffer. I'm not sure if Z buffer works right now, but there is like a clipping from the far away, so I guess it kind of works maybe. And then also I'm going to use position W. So hopefully that will do something, and there you go. God, I hate matrices. So can I move it like even further away? Okay, for some reason I cannot. That's really funny. Huh. Oh yeah, it's actually kind of clipping. So yeah. But there you go. Does anyone still watch the stream? I guess nobody watches the stream anymore. Everyone left. All right. I want to slow down the rotation. That's what I want to do. I want to slow down. Okay, so that looks more or less okay. More or less. Then I also want to scale this entire thing. So here's that stuff. Then how can I scale? I want to scale it like down, like in a half. It's probably gonna, yeah. It also accepts W, so. So if I multiply, it multiplies everyone by. Okay. Okay. So I probably have to do this when I divide vector 4 by 2, 2, 2, and this is 1. Will it work? I wonder. Yeah, it worked. It kind of worked. It's kind of funny how I remember doing the same math when I didn't know OpenGL, but I knew a little bit of like 3D math to render 3D, and I was so surprised when I discovered OpenGL 1.0, so I didn't have to do that everything myself, like everything was baked into OpenGL. And now they took it away and now we're back. But at least you have more control, I suppose. At least you have more control. So this is gonna be the thing that we have here. This is gonna be the thing that we have. So this is the perspective projection I was talking about. Right. So the next thing we probably need to do, we need to texture the cube. Texturing the cube is gonna be kind of interesting, I think. Because you need to also do UV coordinate stuff. So we have a raid from Illustrator with 221 browser tabs. Thank you so much for the rate, and welcome everyone. We're just learning OpenGL, nothing special. So we haven't done anything particularly useful yet. So we managed to render a cube without lighting. So I know nothing about modern OpenGL. And I don't know how to do projections in the modern OpenGL because the only OpenGL I knew was OpenGL 1.0 long time ago. But the modern OpenGL, I don't like it. And I don't know how to do projections, and that's why I do projection like that. So yeah, I was also planning to like texturize the cube, but I'm already finishing the stream, by the way, so I was already about to finish the stream, so you already knew. But we can try to texturize, it shouldn't be that hard. So just load the texture into, yeah, just load the OpenGL texture and just transform UV coordinates accordingly. I'm not 100% sure. It will probably take more time than I would like to, but let's give it a try. Let's give it a try, why not? Let's try to load up a texture. So what we're gonna use as a texture? So let's actually use sodium POG as a texture. Right, so let me copy the link. Yep, and it's gonna be POG PNG. So it's gonna be POG PNG. There we go. So we're gonna use that as a texture. So to load this as a texture, we'll probably need a library that can load PNG files. So we're gonna use STB. STB. STB image, where is the STB? Ah, come on. Something's definitely wrong with my keyboard. Because sometimes it just skips the keys and I don't really like that. Don't really like that. Okay, so here's the raw version of that, and let's do W. Learn OpenGL.com. All of the OpenGL tutorials that I've encountered were horrible. They're absolutely horrible. They just show you some like bullshit examples that could have been way simpler, and those examples don't explain any like fundamental knowledge like behind OpenGL. It's just like repeat this stuff after me, don't try to understand it. All of them are horrible. I cannot read them. Like, I tried so many tutorials, none of them are good. None of them are good at all. Alright. And yeah, and a lot of them have a lot of text in them that talk like some sort of backstory about the pet dog of the author of the tutorial or some shit like that. I don't care. I just want to draw goddamn triangles on my screen. Seriously. How more could you overcomplicate that process? I just need to draw goddamn triangles on my screen. Just let me do that. No, you need to listen to the backstory of my pet dog or a tutorial or something like that. I don't give a shit, seriously. Just want to draw triangles on the screen. That's it. I'm a simple man, just give me simple tools. Alright, so let's actually include the STB. STB image, right. Alright, and if you include STB, you also have to define STB image implementation. Cool. So we need to load the data to STB image. STBI. I think it has to be load. Yeah, this is basically what we need here. So when we're gonna load that, I think we can load it at any point because yeah, it would be better to do that after we establish the context. Yes. Kawaii desu. Alright. We come between mine and his strength. Yes, that's true. Pog PNG. So this is going to be W and H. I don't really care about the amount of components, so I'm gonna just keep it like that then. And this is gonna be null, and I think the last component, I don't remember what the last one represents. I think the desired amount of components, I think I'm gonna say 4. Right, we're gonna use RGBA. And in that case, I think I'm gonna actually try to reinterpret this entire pointer to 32-bit integer. uint32_t. Triangles, I prefer quads as my primitives. Sega Saturn was the clear pinnacle of human technology. I also prefer quads, believe it or not, but OpenGL like really pushes to triangles, so yeah. It is what it is. So in this particular, by the way, this program, yeah, you think I just basically hard-coded all of the vertices of this cube? No, I'm generating the mesh. I'm actually generating the mesh, and this mesh consists of a sequence of triangles. So OpenGL was pushing it so hard, I was forced to generate triangles. Yeah, that's essentially, yeah, this is essentially how we do that. So this is the code that generates triangles for the cube. So we have cube faces, and then we generate each individual cube face with different combinations of different coordinates and stuff like that. Yeah. It's fun. Trust me. It's super fun. Anyways, so yeah, so what I was doing, I was trying to load an image. Did you try triangle strips at all? That's a very interesting question with very interesting connotation. Yes, I have tried them. Let me see. So here's the pixels, right? So we loaded the pixels. Cool. If pixels is null, we're gonna say that we couldn't load anything. It's gonna be std error. Error could not load file, and we're gonna provide the file name. Okay, texture file path. This is what we're gonna provide. Right. We also can provide an explanation, because I'm pretty sure STBI sets error no. Error no, and then we're gonna just exit with 1, something like that. So we need to define a texture file path. Oh my god, Emacs, come on. Pog PNG. There we go. Texture file path. Cool. What's gonna be? I didn't recompile that. I only run it. I need to recompile this entire stuff. It doesn't really. Oh yeah, so another thing about STB is that it generates a lot of interesting warnings that are very annoying, and the author doesn't bother to fix them. So you have to fix them yourself. So I'm pretty sure, so B is integer, so we can actually put an integer here. Yeah, and we don't even need these variables. So out size and delay size, cool. So, and also get rid of that, and I think that's it. Okay, so everything seems to be compiling, and if I try to run the game, it doesn't crash. That means it loaded the texture successfully. It loaded this image successfully, but we cannot see that yet because we need to properly code it. So I think I have an example on how to load the texture. So we can find it in something. I think I have to go to the different place. Right. So yeah. Texture CPP. I'm gonna be stealing some code. Yeah, that's what we have to do here. So we have to generate the texture first, then bind the texture, set up the like magnifier, minifier, filters, parameters, wrapping, and then provide the data to the texture, and then generate maps. And that texture will be automatically active for you. So I think that's exactly the code that we're gonna copy paste, because that's what software development is all about, isn't it? You just copy paste the code. But luckily I'm copy pasting my own code that I wrote myself, that I copy pasted from a different place. Anyways, so here's the generate texture. Maybe I have to actually do that after I set up debug output. I think it would make more sense. Alright, so we are generating that. So this is going to be GL uint texture ID. It's going to be texture ID. We're going to bind the texture as a 2D texture. Texture ID. So then we need to generate all of these like parameters that I didn't really care about. We're gonna use a linear interpolation because we don't want to see them pixels. All right, oh my god. Sometimes it's kind of interesting. It's something with my mouse or with the website. I'm pretty sure it's something with my mouse. My mouse is very old, to be fair. So, and here we have pixels. So after that, I really like how OpenGL is not designed to be understood. It's not designed to be understood. It's designed to be copy-pasted. It's just... Oh shit. Because you can never remember all these parameters. You can vaguely remember the concept, but you can never remember the parameters. Okay, is it gonna compile? Is it gonna compile? It probably seems to be. It seems to be compiling though. Okay, so UV coordinates. What we're gonna use as UV coordinates? I guess we have to just output UV coordinates. I think we already can use the coordinates in the mesh. So essentially, I can try to do the following thing, where I'm gonna say out vec2, and it's gonna be UV. And in this particular case, I'm gonna just use position. Oh, this one is gonna be very interesting. Ooh. I cannot just use XY. I literally cannot just use XY. So I probably have to have like a separate buffer for that. We'll have to create a separate buffer for that. I can try that to do that like for now, and only one face is probably gonna be textured, but that's totally okay. Frag, okay. So in terms of a frag, I also have to have a uniform sampler 2D, and this is going to be the texture, right? I think I have to call it, let's call it POG. So this is going to be a sampler POG, and we're going to accept also in vec2 UV. There we go. So we're not going to set any colors in here, but what we're going to set is texture POG UV. I think this is how we do that. And this is definitely not going to work. Also, we need to set that texture there. Or maybe we don't. Maybe since it's automatically 0, it doesn't need to be set or anything. Okay, so let me try to compile this entire thing and see if it's going to do anything at all. All right, it's doing things. Ah, that's pretty cool. So yeah, the original texture was looked like this, and this is the result. This is the result. Not bad at all, am I right? Not bad at all. I think we need to tesseract. Yeah, it's almost like a tesseract. Amazing, I know. So the most fun part of graphics programming is the glitches that you get along the way. I think that's kind of fun. All right. I think we need to also apply the transformations to the UV coordinates. UV coordinates. I think that's kind of important. Okay. But in this particular case, I don't think we need to do mesh fix up. It's like that, except we don't need to do mesh fix up. I can try to do that. Right. It's gonna be just. All right. Vec4. TUV. So it's kind of similar to like that, except we don't do any fix-ups and probably no transformations as well. So it's going to be just that and just that. And yeah, probably also don't do any of this stuff. So we just take a position, we just do the rotation, right? We just do the rotation, and then we just use TUV XY, and I think that will kind of work. And did it recompile? It didn't even recompile, so I have to do it like that. And it literally didn't do anything. Nice. So I guess what we have to do, we have to actually like have a separate buffer with UV coordinates, right? With UV coordinates, and just keep it there. But unfortunately, I'm already streaming for 5 hours, and it's getting really difficult for me. So I think I'm gonna just commit whatever we have. So I think I'm with me. Can I put like minus in here, like it's half done? Yeah, let's put 0 here. And all right, implement mesh generator. Implement poorly textured cube, something like that. Poorly textured cube. All right, so yeah, I'm already streaming for 5 hours. We had some progress. My initial idea was to have this generate cube, render the cube with perspective projection. We have some sort of perspective projection. I couldn't do the perspective projection through a matrix because I'm too dumb for that. I am really apologize for this. But I managed to do the one, like the simplest one, where you just take X and Y and divide them by Z. That worked, and we did have over texturing. So I was hoping that for texturing I won't have to do like generate UV mesh thingy. But looks like I have to, so, but yeah. But at least we have something like texture-like in here, and at least you can see like one eye of the emote, of certain Pogo emote. So yeah, we're like a little bit over the half of the way through, so yeah, but unfortunately, boys and girls, it is time for me to go. You can check out the source code of this entire thing probably here somewhere. I don't know. Did I put it anywhere? Did I even push any of the... Yeah, I did push some changes, so I think the source code could be found somewhere here. Yeah, this one. Actual 3D graphics in OpenGL. Okay, so check out the source code of this thing that we did today. Check out our schedule page for more information on different projects we're working on. Tomorrow we're gonna continue doing, tomorrow we're gonna do a game development. So this was just an experiment on how to do actual 3D in OpenGL, but tomorrow we're gonna continue developing our game, which is 2D, but it also uses OpenGL, so make sure to join tomorrow. Check out our VODs channel, where we archive all of our stream recordings, so this stream is going to be there as well. And check out our Discord server for offline discussion with the community. And yeah, I wish I could rate somebody, but I'm pretty sure Twitch is going to be very slow. So let's try to rate somebody. I don't know, I have a potato laptop, so it's kind of difficult for me to open Twitch while streaming simultaneously. So it's usually very, very difficult. Right off the bat, I don't see anyone who I would like to raid, because we raided those people relatively recently. So let me see who else we could raid. So game dev and advanced C++. Let's take a look at this thing. Looks interesting. Is there any sound?
No.
There's no sound.
No.
Okay, so we don't rate people without sound. Okay. Alright, get ready for the raid, boys and girls. Get ready for the raids. And I see you all tomorrow. Love you all.